The next point is here. The power of a signal is not affected by time shifting, time reversal, as well as the time scaling. So power of a signal is not affected by time shifting, time reversal, and also time scaling. So basically, here what I am trying to tell you, see here, suppose f of t has the energy E and the power P. And f of t plus or minus c naught will have the energy E as well as the power P. And f of minus t also will have the same energy and power P. And here also power is same. So therefore what I am trying to tell you, which is the power of a signal is not affected by time shifting, time reversal, as well as the time scaling also. So this is a very, very important thing always you have to keep in your mind. So the power of a signal is not affected by time shifting, time reversal, as well as time scaling. But another signal is not affected by time shifting and time reversal, but it is only affected by time scaling. So this is an important point always you have to keep in your mind. So therefore, the power of a signal is not affected by time shifting, it is not affected by time reversal, and it is also not affected by time scaling. So this important property always you have to keep in mind, which is the power of a signal is not affected by time shifting, time reversal, and time scaling also. The power of a signal is not affected by time shifting, time reversal, and time scaling also. So this is a very important point always you have to keep in your mind. Whereas the energy of a signal is not affected by time shifting and time reversal, but is only affected by time scaling. So finally I can say the energy of the signal is not affected by time shifting, time reversal, but it is affected by only time scaling. Whereas the power of the signal is not affected by time shifting, time reversal, and time scaling. So these two important things always you have to keep in your mind. The next point is when two discrete time signals are convolved. So we are going to discuss some facts regarding that. We are going to discuss some important facts. So we are going to discuss some important points regarding when two discrete time signals are convolved, what is going to get happen. The lower and the upper limits for resultant of convolution is equal to sum of individual lower and upper limits of the signal being convolved. The lower and upper limits for resultant of convolution is equal to sum of individual lower and upper limits of the signal being convolved. And the length of the resultant of convolution is L plus K minus 1, where L is the length of x of n, means number of samples present in x of n, and K is the length of h of n, which is number of samples present in h of n. So this one number of samples are going to present in the resultant of the convolution. And you know, y of n is nothing but x of n convolution of h of n. So sigma of y of n is equal to sigma of x of n into sigma of h of n. So these three important points always you have to keep in your mind. So what is the meaning of this one? Listen carefully. Suppose when two discrete time signals are there, and if you are going to get convolved, the lower and upper limits for the resultant of convolution is equal to sum of individual lower limits and the individual upper limits of the signal being convolved. And the length of the resultant of the convolution is L plus K minus 1, where L is the length of x of n, is number of samples present in x of n, and K is the length of h of n, is number of samples present in h of n. And sigma of y of n is equal to sigma of x of n into sigma of h of n. So how to give a small example I will try to give you so that you can easily able to understand. Suppose x of n is there. X of n, suppose, let me assume 1, 2, 1. So this is like this. Then x of n is there, and this is h of n. So this is the h of n. H of n is nothing but 2, 4, 3, 6. If it is there like this, then this is like this one. You say the starting point is from n is equal to 0. It is present to the RHS. So y of n is nothing but x of n convolution of h of n. So for y of n, what is the lower limit? The lower limit is nothing but is the lower limit. The lower limit is nothing but basically summation of two lower limits. Here it is 0, here it is 0. N is equal to 0, n is equal to 0. Here 0 is equal to n is equal to 0. And what is the upper limit? Summation of two upper limits. Here the upper limit is n is equal to 0, n is equal to 1, n is equal to 2 here. And here n is equal to 2. N is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 3, and n is equal to 2. 2 plus 3 is equal to 5. The upper limit is here, n is equal to 5. So here, finally, we have signals up to here n is equal to 5, here n is equal to 5, it will be there. So here, so the lower and the upper limits for resultant of the convolution is equal to sum of the individual lower and the upper limits of the signals being convolved. And the length of the resultant of the signal is a plus k minus 1. So L is the length of x of n, is number of samples present in x of n. So L is nothing but number of samples present in x of n, which is equal to 3. And k is nothing but length of h of n, is number of samples present in h of n, which is nothing but n4. So then the length of resultant of the signal y of n is nothing but L plus k minus 1, which is 3 plus 4 minus 1. 3 plus 4 is nothing but 5. 4, 5, 6, 7. 7 minus 1 is equal to 6. So here n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. So total 6 samples are there. N is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. So total we have 6 samples. Yes, 6 samples are there. And what is sigma of y of n? So you know y of n is equal to x of n combination of h of n. So sigma of y of n is equal to sigma of x of n into sigma of h of n. So what is the meaning of this one? Suppose I want to know the addition of all these values. Suppose if I want to know what is the addition of all these values, it is equal to the addition of all these values into addition of all these values. So if I want to know the addition of all these values is nothing but addition of all these values into addition of all these values, which is sigma y of n is equal to sigma x of n into sigma h of n. So finally, I can say that when two descriptive signals are convolved, the lower and upper limits for the resultant of the convolution is equal to sum of individual lower limits and the individual upper limits of a signal being convolved. And the length of the resultant of the convolution is L plus k minus 1, where L is the length of x of n, which is number of samples present in x of n, and k is the length of h of n, means number of samples present in h of n. And sigma of y of n is equal to sigma of x of n into sigma of h of n. So these formulas always you have to keep in your mind. So finally I can say, suppose this is the x of n and this is the h of n. So y of n is equal to x of n convolution of h of n. So therefore the lower limit is nothing but summation of two lower limits, and the upper limit is nothing but summation of two upper limits. Means like this. The number of samples present in y of n is nothing but L plus k minus 1, where L is the samples present in x of n and k is the number of samples present in h of n. And similarly, y of n is equal to x of n convolution of h of n. So sigma y of n is equal to sigma x of n into sigma h of n. Means I want to make summation of all these values is equal to summation of all these values into summation of all these values. So finally I can say, when two discrete signals are convolved, the lower and the upper limits for the resultant of the convolution is always equal to the sum of individual lower and the upper limits of the signals being convolved. And the length of the resultant of the convolution is always equal to L plus k minus 1, where L is the length of the x of n, means number of samples present in x of n, and k is the length of h of n, means number of samples present in h of n, where sigma y of n is equal to sigma x of n into sigma h of n. So finally I can say, when two discrete signals are convolved, the lower and the upper limits for the resultant of the convolution is always equal to the sum of the individual lower and the upper limits of the signals being convolved. And the length of the resultant of the convolution is always equal to L plus k minus 1, where L is the length of x of n, means number of samples present in x of n, and k is the length of h of n, means number of samples present in h of n. And sigma of y of n is equal to sigma of x of n into sigma of h of n. So these things always you have to keep in your mind. So now the next point is here we will go for the next point. When two continuous time signals are convolved. So previously we have learned what is the thing which will happen when two discrete time signals are convolved. Now we will discuss for two continuous time signals are convolved, and what is the things are going to happen. Let us see. The lower and the upper limits for resultant of convolution is equal to sum of individual lower and the upper limits of the signals being convolved. The lower and the upper limits for the resultant of the convolution is equal to sum of the individual lower limits and the upper limits of the signals being convolved. And width of the resultant is equal to sum of the width of individual signals being convolved. Width of the resultant is equal to sum of width of individual signals being convolved. And area of the resultant is equal to the product of the area of the individual signals being convolved. So these points always you have to keep in your mind. So when two continuous time signals are convolved, the lower and upper limits for resultant of the convolution is equal to sum of individual lower and the upper limits of the signals being convolved, and width of the resultant is equal to sum of the width of individual signals being convolved and area of the segment is equal to the product of the area of the individual segments being converged. If you compare the discrete and the continuous, the concept is same. Here sigma is nothing but area, and sigma will become area. Sigma will become area, and sigma will become area. But here there will be no minus 1, just addition of 2 bits, just do the addition of 2 bits. That's it. Just do the addition of 2 bits, and the remaining thing is same. So when two continuous time signals are convolved, the lower and the upper limits for the resultant of the convolution is equal to sum of individual lower and upper limits of the signals being convolved, and the width of the resultant is always equal to sum of the width of the individual signals being convolved, and area of the result is equal to the product of the area of the individual signals being convolved. So this points always you have to keep in the mind. So therefore we can say when two continuous time signals are convolved, the lower and the upper limits for the resultant of the convolution is always equal to summation of the individual lower and the upper limits of the signals being convolved, and the width of the resultant is always equal to sum of the individual signals being convolved, and the area of the result is equal to the product of the area of the individual signals being convolved. So finally, I can say only one important thing. So here, basically, if you go for the continuous time nature, you can say the only thing is here, the lower and the upper limits for the result of the convolution is always equal to sum of the individual lower limits and the summation of individual upper limits of the signals being convolved, and the width of the resultant is equal to summation of the widths of individual signals being convolved, and the area of the resultant is equal to the product of the area of the two signals being convolved. The product of the area of the individual signals being convolved. So these things always you have to keep in your mind. So I can say that we can see small example. Let me take here. So this is the x of t and this is the h of t. So y of t is equal to x of t convolution of h of t. So now here basically suppose x of t starting point is t1, ending point is, let me take here some t, take some final point is some tn. Here the starting point is, let me take here this is suppose let me take this is starting point. So a small correction, let me take here starting point as some t1 and here the ending point is t3. Suppose here let me take the starting point as some t1 and here starting time t1 and the ending time is p3. Then what is that? The y of t, what is the starting time? The starting time is nothing but t1 plus p1. And what is the ending time? Just p3 plus p3. Similarly, then what is the resultant width? What is the resultant width? The resultant width is the addition of the 2 bits. Whatever the width of this one and width of this one, do the addition of these two things. That's it. Just p3 minus p1 plus p3 minus p1. This is the resultant width. Then what is the area of the signal? Area of the signal y of t is equal to area of the signal x of t into area of the signal h of t. So therefore, this is the point of which you have to keep in mind. So you can say when two continuous time signals are convolved, the lower and the upper limits for the resultant of the convolution is always equal to the sum of the individual lower and upper limits of the signals being convolved, and the width of the resultant is always equal to sum of the widths of the individual signals being convolved, and the area of the result is always equal to the product of the area of the individual signals being convolved. So these points always you have to keep in your mind. So now let's go for the other point, which is when two pulses of same width convolved, we get triangular pulse. When two pulses of same width convolved, we are going to get the triangular pulse. And in first half, it rises with slope plus a1 into a2, and in second half, it is going to, and in the second half, it comes with the slope of, it decays with the slope of minus a1 a2, minus a1 a2. Where a1 is the amplitude of the pulse first pulse and a2 is the amplitude of the second pulse. So listen carefully. When two pulses of same width convolved, we are going to get the triangular pulse. And in the first half, it is going to rise with the slope a1 a2, and in the second half, it is going to comes with the slope of minus a1 a2. Now a1 is the amplitude of the first pulse and a2 is the amplitude of the second pulse. So why it is like this? Let us do a small concept here. Suppose this is the first pulse. Here, let me assume here it is having a amplitude of a1. Here it is having a width of t1, width of t1. Suppose there is another signal. The signal is having amplitude A2, and here the width is T2. Sorry, T1. Both are having the same time, same width. Both are having same width. Then, what is if you are going to convert these two signals, the resultant signal will have the width summation of the individual summation of individual widths, which is T plus T is nothing but 2T. So this is the total 2T. Out of this, we will go for T half portion and half portion. So it is basically a triangular construct. So this is a triangle and this is also triangle. So here it is going to rise with the slope of plus A1 into A2. This is going to decay with the slope of A1 A2. So here is a point of this you have to keep in your mind. Therefore, if two pulses of same width converge, we are going to get the triangular pulse. And the first half is going to rise with the slope of A1 A2, and in the second half it is going to decay with the slope of A1 A2. A1 is the amplitude of the first pulse and A2 is the amplitude of the second pulse. So finally, I can say here, suppose this is a rectangular pulse, it is having an amplitude of A1 at time t, and there is another rectangular pulse of amplitude A2 at a time of width of t. So both are having the same width. If you convert the resultant signal, width is nothing but summation of the individual widths, which is T plus T is nothing but 2T. Overall is 2T. So out of this half portion rising and half portion decaying is a triangular pulse. It is going to rise with the slope of plus A1 A2 and is going to decay with the slope of minus A1 A2. So plus A1 A2 minus A1 A2. So this is the overall combination of these two signals. So this point always you have to keep in your mind. So now the next point is, when two pulses of unequal widths are convolved, then resultant is always a trapezoidal pulse. So we are going to get a trapezoidal pulse whose width is the sum of the individual widths, and width of rising arm and the falling arm are same and equal to the width of the smaller width pulse, and the slope of the rising arm is equal to the product of the individual values of the pulses. So what is the meaning of this one? See, when two pulses of unequal widths are convolved, then the resultant is always a trapezoidal pulse, whose width is the sum of the individual widths. Width of the rising arm and the falling arm are same and equal to width of the smaller width pulse, and the slope of the rising arm is equal to the product of the individual values of the pulses. So what is the meaning of this one? Let me explain. Suppose small example. Let me take. Suppose this is a rectangular pulse. It is having a amplitude of A1 and it is having a width of T1. Suppose let me take another signal. It is having amplitude A2 and the width is T2. Suppose if I am going to convert these two signals, here the width is different. Then if we convert, we are going to get a trapezoidal signal we are going to get. So we are going to get a trapezoidal signal. So trapezoidal signal means like this we are going to get. So then this resultant signal will have the width, the summation of the individual widths, is T1 plus T2. The total width is T1 plus T2. The width is T1 plus T2. So the width of the rising arm and the width of the falling arm is same. It is nothing but, let me assume T1 is less than T2. This width is nothing but T1 on this minimum value. Here also T1. So this is a T1 and this is also T1. The remaining portion is nothing but simply T1 plus T2 minus T1. T1 plus T2 minus T1. The remaining width we are going to get if the slope is equal to 0. Here what is the slope? A1 into A2. Here the slope is plus 7A2. The slope is minus 7A2. That's it. So this is what I am trying to tell you. So therefore you can see clearly from this picture I have told you, when two pulses of unequal widths are convolved, then the resultant is always a trapezoidal pulse, whose width is a summation of the individual widths, and the width of the rising arm and the falling arm are same. So whatever the width of the rising arm and the falling arm are same, and which is equal to the width of the smaller width pulse, and the slope of the rising arm is equal to the product of the individual values of the pulses. As you can see clearly, suppose I have taken two rectangular pulses of amplitude A1 and A2 of different widths T1 and T2. So if we are going to convert, then we are going to get a trapezoidal pulse. If equal width means we are going to get triangular pulse. If different widths means we are going to get the trapezoidal pulse. So in this case, I am going to assume T1 is less than T2. So we are going to get a trapezoidal pulse, right? So the overall width is the summation of the individual widths T1 plus T2. So here rising and here decaying. So So these widths are same, which is equal to minimum value of T1 and T2. Out of this minimum value is T1. So this width is T1 and this width is T1. Like the remaining width is nothing but T1 plus T2 minus 2T1, which is nothing but T2 minus T1. This remaining width is nothing but T2 minus T1. So this is nothing but T2 minus T1 is the remaining width. Remaining width we are going to get. So for this width, the slope is 0. But here it will have some slope. The slope is nothing but A1 into A2 plus A1 A2. And this slope is nothing but minus A1 A2. So this is a point. These two things will have the same amount of the slope. One is rising and the other is decaying. And the remaining thing is 0. So this point always you have to keep in mind. So now the next point is convolution of the two causal signals is again a causal signal. So convolution of two causal signals is always a causal signal. Causal signal means I have already told you. What is the meaning of causal signal? Causal signal means here f of t is equal to 0 for t less than 0. Then we can say that signal is said to be a causal signal. So whenever we are going to the convolution of two causal signals, the resultant signal is always again a causal signal only. So that is a point always you have to keep in your mind. So whenever you are doing the convolution of two causal signals, always we are going to get a causal signal only. So always you are going to get a causal signal only. So what is the best example? What is the best example we can say? So you can, if you want the best example, I can say like this, which is u of t convolution of b, u of t convolution of r of t. So what is the thing here? You know u of t. So u of t is a thing that convolution is, we can say u of t convolution of r of t. What is the thing that we are going to get? Simply you are going to get again a causal signal only. We are going to get a causal signal only. So convolution of two causal signals, you are always going to get a causal signal only. So convolution of two causal signals, always you are going to get a causal signal. So what is the meaning of causal signal? Causal signal is nothing but here. Causal signal means when f of t is equal to 0 or t less than 0, then it is called as a causal signal. So convolution of two causal signals is again a causal signal. So convolution of two causal signals, always you are going to get a causal signal. Causal signal means f of t is equal to 0 for t less than 0, then it is called as a causal signal. So convolution of two causal signals is always going to give a causal signal. So causal signal means f of t is equal to 0 for t less than 0. The next point is e to the power of minus 80 into u of t convolution of e to the power of minus bt into u of t is equal to 1 by b minus a into e to the power of minus 80 minus e to the power of minus bt into u of t. So this formula I have already told you, but you have to remember in examinations. If you try to do all those things, it will take a lot of time. But if you remember this one, it is easy. So that is the reason I have given this one. You can solve this question even by Laplace method. It is a very piece of cake. It's a very piece of cake. But still, you have to remember. So if you do this one, the time domain, it will take a lot of time. But if you do the same question in the Laplace domain, it will take a fraction of a second only. So it's a very piece of cake. So I have already told you convolution time domain belongs to the product in the S domain also. So therefore, e to the power of minus a to u of t convolution of e to the power of minus b to u of t is equal to 1 by b minus a into e to the power of minus a t minus e to the power of minus bt into u of t. So you can see these two signals are causal signals. So convolution of two causal signals, always you are going to get a causal signal again. So therefore, e to the power of minus a t convolution of e to the power of minus bt u of t is equal to 1 by b minus a into e to the power of minus a t minus e to the power of minus bt into u of t. Then e to the power of n, u of n, convolution of e to the power of n, u of n is equal to e to the power of m into n plus 1 into u of n. Or you can say n plus 1 into e to the power of m into u of n. U of n. So this is also causal signal and this is also causal signal. So when you do the convolution of two causal signals, again you are going to get a causal signal. So these two formulas always you have to remember, which is e to the power of minus 80 u of t convolution of e to the power of minus bt u of t is equal to 1 by b minus a into e to the power of minus 80 minus e to the power of minus bt into u of t. Similarly, e to the power of n u of n convolution of e to the power of n u of n is equal to e to the power of n into n plus 1 into u of n. So convolution of two causal signals, always you are going to get a causal signal. H of n or h of t must be a causal signal. Then the LTI system is said to be a causal LTI system. H of n or h of t must be a causal signal. Then the LTI system is said to be a causal LTI system. I have already told you. The LTI system is said to be causal when h of t is equal to 0 for t less than 0. So listen carefully. An LTI system is said to be causal system when h of t or h of n is equal to 0 for n less than 0. What is the meaning of this one? If h of t or h of n is a causal signal, or we can say right-sided signal, by default we can say the system is also causal. So when h of t or h of n is a causal signal, then the overall LTI system is also said to be a causal system. So h of n or h of t must be a causal signal in the LTI system is said to be causal LTI system. So finally I can say h of n or h of t must be a causal signal, means h of n or h of t should be equal to 0 or t less than 0. Then only we can say it's a causal signal. So therefore that's corresponding LTI system is also called as the causal LTI system. So finally a system LTI system as an LTI system is said to be causal system when h of t is equal to 0 for t less than 0 or h of n is equal to 0 for n less than 0. Then we can say that system is said to be a causal system. Once the signal is said to be causal signal, then only the system is said to be a causal LTI system. So these things always you have to keep in your mind. Now we are going to discuss another point, which is our aim in this subject is to write the different expressions, different expression ways of writing the response. So our aim in this subject is to write the different expression ways of writing the response. I have already told you. So basically in the signal system, we are going to learn the different ways of writing the response, different techniques. So in the convolution, I have already told you y of t is called x of t convolution of h of t. But in the Fourier transform, y of omega is equal to x of omega into h of omega. Similarly, in the Laplace domain also, I have already told you y of s is equal to x of s into h of s. So we have discussed the different ways of writing the response, the different ways of writing the response. As you go further, as you go from chapter 1 to chapter last, the amount of time taken to get the answer is going to get decreases. So when in the signal system, whenever you go from first chapter to the last chapter, the amount of time taken in order to get the result of the output for the LTI system is going to get decreases. So therefore this is the point always you have to keep in your mind. So our aim in this subject is to write the different expression ways of writing the response. So therefore our aim in this subject is to write the different expression ways of writing the response. So this point always you have to keep in your mind. The only aim in this subject is to write the different expression ways of writing the response. The next point is the tools required in this course are the Fourier series, Fourier transform, Laplace transform, jet transform. All these are called as the mathematical tools. I have already told you the tools which are basically required in this course are the Fourier series, Fourier transform, Laplace transform, jet transform, and these are the mathematical tools. So basically here, suppose in the signal system we have to learn certain tools, certain mathematical tools. These things we are going to discuss in detail. I have already discussed all these mathematical tools in a very detailed manner. Fourier series is applicable for the periodic signals, and Fourier transform is applicable for the aperiodic signal. So Laplace transform for the time domain signals and the continuous time domain signals, and the jet transform for the discrete time domain signals. These points I have already told you. So the tools which are required in this course are the Fourier series, Fourier transform, Laplace transform, and jet transform. These are the mathematical tools which are used in the signal system course. So therefore we can say the mathematical tools which are required in this course are the Fourier series, Fourier transform, Laplace transform, and the jet transform. Fourier series is for the periodic signals, Fourier transform is for the aperiodic signals, Laplace transform is for the continuous time domain signals, and jet transform is for the discrete time domain signals. The next point is V of t, I of t are the signals we always deals in this subject. So V of t, I of t are the signals we always deals in this subject. V of t means we can say the voltage signal, I of t means the current signal. Only these two signals which we are going to discuss in very detail in this subject. So only voltage signal and current signal, these are the signals we are always going to discuss only these signals in our subject, in the signal system course subject. So we can say the voltage signal and the current signal, only these signals that we are going to discuss in a very detail in this subject. So only the voltage signal and the current signal, only these two signals which we are going to deal very too much in this subject. The next point is by using red, green, blue, combination of different intensity, we can get all varieties of colors. This is a very basic concept. I no need to further explain, but let me tell you. So by using red, green, blue, combination of different intensity, we can get all varieties of colors. See, I've already told you one important point. Suppose if you have red color, so if you have red color, so if you have red color, if you have red color, and if you have brown, if you have green color, if you have green color, and if you have blue color. So by using the different intensity, we can get any color that we want. So by using the red color, green color, and blue color combination of different intensity, we can get all varieties of colors. So therefore, these are called as the basic colors. Red color, green color, and blue color. These are called the basic colors. So by using the different intensity and by combining all these three colors of different intensity, we can get back whatever the color that we require. So these are the basic colors that you always have to keep in your mind, which are the red color, green color, and blue color. So red color, green color, and blue color, we can say these are the three colors which are basically the basic colors. So by using different intensity of these three colors and combining them, we can get any color that we really want. So by using the red color, green color, and blue color combination of different intensity, we can get all varieties of color. So finally, I can say that by using the red color, green color, blue color of different intensity combinations, we can get whatever the color that we really want. So finally, I can say by using the red color, green color, and blue color of different intensity, we can get whatever the color that we really want. So finally, I can say by using the red color, green color, blue color of different combination by using the combination of these things of different intensity, we can get back whatever the color that we really want. So this point always you have to keep in your mind. Now the next point is, generally function can depend on any number of variables, but we strictly focus on only one variable signal. Generally a function can depend on any number of variables, but we strictly focus on only one variable signal. So basically we can take, so suppose we take any function, generally it can depend more than one variable. It can be one variable, two variable, three variable, it can be anything. But in our course, we are going to only study those things where the function is going to depend only on one variable. So here we are going to discuss only those functions which are depending only on one variable. But practically, if you see, the functions are depending on what number of variables. But in our course, we are going to stick to only for one variable signal. So generally, a function can depend on any number of variables, but we strictly focus on only one variable signal. So finally, I can say generally a function can depend on any number of variables, but we strictly focus on only one variable signal. So finally, I can say that any function, any general function, it can depend on more than one variable of signal. We can say it can depend on any number of variables, but we strictly focus only for those signals which are depending on only one variable. The next point is, in sine signal, zero crossing will occur at n point, where n is an integer. N is equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, and goes on. See, in the case of sine signal, we are going to occur with 0 at the angle theta is equal to n point. So, as I am telling you, in sine signal, zero crossing is going to occur at theta is equal to n point, where n is an integer. So, I have already told you. See, for a sine function means sine theta. So sine theta is equal to 0. Sine theta is equal to 0 for theta is equal to n pi, where n is the integer. N is the integer. Integer means we can say it is 0, plus or minus 1, plus or minus 2, and goes on. So this is upon always you have to keep in your mind. So we can say in the case of sine signal, zero crossing is going to get occur at theta is equal to n pi, where n is an integer which is 0 plus or minus 1 plus or minus 2 and goes on. So finally I can say in the case of sine signal, zero crossing is going to get occur at theta is equal to n pi, where n is an integer which is n is equal to 0 plus or minus 1 plus or minus 2 and goes on. Now in the cosine signal, zero crossing, here let me write this is 0. So this is 0, ZERO. So in the cosine signal, zero crossing will occur at theta is equal to 2n plus 1 into pi by 2, where n is an integer, which is 0 plus or minus 1 plus or minus 2 and goes on. So this point always you have to keep in your mind. So and similarly, what is a cos theta? So cos theta is equal to 0. So cos theta is equal to 0 and theta is equal to 2n plus 1 into pi by 2, where n is an integer. N is an integer. N is an integer. So n can be either 0 plus or minus 1 plus or minus 2 and goes on. Suppose if n is equal to 0 means we are going to get pi by 2 plus cos pi by 2 is equal to 0. So these two things always you have to keep in your mind. So sine function, for sine function we are going to have, so for sine function 0 will occur at theta is equal to n pi, where n is an integer, means 0 plus or minus 1 plus or minus 2 and goes on. Similarly for cos function, the cos function will give you 0 when theta is equal to 2n plus 1 into pi by 2, where n is an integer, which is 0 plus or minus 1 plus or minus 2 and goes on. So these things always you have to keep in your mind. So finally I can say sine function, your sine function is, sine function will have the 0 at theta is equal to n pi, where n is an integer, which is 0 plus or minus 1 plus or minus 2 and goes on. And cos function is 0 at theta is equal to 2n plus 1 into pi by 2, where n is an integer, which is 0 plus or minus 1 plus or minus 2 and goes on. So these two things always you have to keep in your mind. The next thing, the area under the impulse function is always equal to unity. So integration of t is equal to minus infinity plus infinity. Delta of t into dt is always equal to 1. So the area under the impulse function is always equal to unity. So area under the impulse function is always equal to unity, which is integration from t is equal to minus infinity plus infinity. Delta of t into dt, its value is always equal to 1. Because I've already told you the area under the impulse function is always equal to unity. So area under the impulse function is always equal to unity. So therefore, integration of minus infinity plus infinity, delta of t dt is always equal to 1. So always remember, the area under the impulse function is always equal to unity, which is integration of t is equal to minus infinity plus infinity, delta of t dt is always equal to unity. The next thing is, to get an expression f of a t plus or minus b for the signal f of t, which involves the combination of the time shifting and time scaling. The natural order of performing them without any precaution is time shifting first followed by time scaling. However, shifting can also be performed after scaling with the precaution of divide the visible shift amount by the scaling factor. So what I am trying to tell you is very simple. See, f of a t plus or minus b, I already told you how to do the operation. First you have to go for the shifting, then you have to go for the scaling. This is the natural way. Suppose if you want to perform scaling, then shifting, then you have to keep in your mind some precaution. But if you are going to perform the shifting, then scaling, you don't have to think anything. Just go for the blindly procedure without any precaution. But if you want to do it in the reverse fashion, then you have to keep in your mind there is some precaution. What is that? I will tell you. But you have to think in your mind. So in order to get an expression f of a t plus or minus b for the signal f of t, which involves the combination of time shifting and time scaling, the natural order of performing them without any precaution is time shifting first followed by time scaling. However, shifting can also be performed after scaling with the precaution of divide the visible amount by the scaling factor. So what I am trying to tell you is f of a t plus or minus b. If you want to get this signal from f of t, there is a natural method is there. First to perform the time shifting, then you go for the time scaling without any precaution. But if you want to do it in the reverse fashion, first scaling, then shifting, then you have to do some precaution. You have to keep some precaution in your head. So what is that? I will tell you. Suppose there is a small example, f of 2t plus 5. F of 2t plus 5. So first thing is I will go for the natural procedure. What is natural procedure? First I will go for the shifting. So z of t is equal to f of t plus 5. This is the shifting I will go. Then what I will do? I will go for the shifting. Then I will go for the scaling, which is z of 2t is nothing but f of 2t plus 5. In place of t I have replaced t by 2t. Then I am going to get this one. So first thing is I have did the shifting property. So first thing is I have did the shifting property, and then I have did the scaling property. So this is the natural way. So first do the shifting, then do the scaling. Then you don't have to think anything about anything. So just go by this procedure, then you are going to get the signal of f of 2t plus 5 from f of t. So therefore we can say first thing is I have performed the shifting, which is z of t is equal to f of t plus 5. Then I did the scaling. Z of 2t is equal to f of 2t plus 5. So first thing is I did the shifting, then I did the scaling. Then we are going to get the signal f of 2t plus 5 from f of t. Suppose if you want to do the reversing, then what I have to do? First I am going to do the scaling here. So first thing is I am going to do the scaling. So z of t is equal to f of 2t. Then what I will do? I will do like this. Then I will do shifting. I will do now shifting by 5 by 2. So now I will do shifting by 5 by 2. So f of t plus 5 by 2. I will put in place of t I will substitute t plus 5 by 2. Then I am going to get finally 2 into t plus 5 by 2 which is called 2t plus 5. So therefore this is the thing that you have to do. So here if you want to perform the natural way, go for the shifting by 5 and then scaling by 2. If you want to perform the unnatural method, it's artificial method, then first you are doing the scaling by 2 and then we are going to do the shifting by 5 by 2, but not 5. So this is a thing always you have to keep in mind. So that is the reason I recommend you to go for the natural procedure. So this is a natural procedure. So if you go for the natural procedure, then there is no pain in the neck. So then there is no pain in the neck. Otherwise, there is a lot of pain in the neck. So I want you to go for this natural procedure. Even though you can perform this one also, but you should know the concept. And you should know the concept. But if you do this one, just blindly go for the shifting and scaling, then everything is perfectly alright. So this point always you have to keep in your mind. So for this one, first I have did the shifting by 5, then I have did the scaling by 2t, then it's 2. Then here I did the scaling by 2, then I have given the shifting by 5 by 2. So this is something always you have to keep in your mind. So that is the reason. However, shifting can also be performed after scaling with the precaution of divide the visible shift. So divide the visible shift. So divide the visible shift. Divide the visible shift by the scaling factor. So divide the visible shift by the scaling factor. Shift is 5, scaling is 2. So divide these two things. So first thing is the scaling they have done, and then they have done the shifting. So whatever the shifting is nothing but the precaution is divide the visible shift by the amount of scaling factor. So this point always you have to keep in your mind. So that is the reason I recommend you to go for the natural procedure. First go for the shifting, then go for the scaling. Reverse also possible, but only thing is you should know the concept. Then next point is to get a signal f of minus t plus or minus b for the signal f of t, which involves the combination of time shifting and time reversal. The natural order of performing them without any precaution is time shifting first followed by time reversal. However, shifting can also be performed after reversal with the precaution of change in the nature of the visible shift transformation. That is, if it is a visible to delay change into opposite nature, advance and vice versa. Same thing, same concept, right? Here A is nothing but minus 1. F of at plus or minus b, A is equal to minus 1. The concept is same. This is a special case of this general format. So here, what is the natural procedure? First go for the shifting, then go for the time scaling. Time scaling is nothing but minus 1 here. So that means sometimes we call this as a reversal also we say. But the concept is same. First go for the time shifting, then go for the time scaling. Then you can do in the reverse fashion also. I have already told the reverse fashion is scaling, then go for the shifting also I have already told. But here you need to have some precaution. But if you go for the natural procedure, then there is no precaution. So therefore finally I can say that first go for the time shifting, then go for the time scaling. So this is a natural procedure. I recommend you to always go for the natural procedure. Don't go for the other method. But if you want to go for the other method, still you can go. But you need to keep in your mind the concept, and only you can do that one. So in order to get a signal f of minus t plus or minus b for the signal f of t, which is going to involve the combination of the time shifting and the time reversal. The natural order of performing them without any precaution is the time shifting first followed by the time reversal. However, shifting can also be performed after reversal with the precaution of change in the nature of the visible shifting transformation. That is, if it is visible to delay change into opposite nature, advance and vice versa. So let me tell you the concept. F of minus t plus 4. I want to perform this one. So first I will do time shifting. So first I will do the time shifting, which is nothing but z of t is equal to f of t plus 4. Then I will do the time scaling. Time scaling I will do. So time scaling is nothing but I will replace t by minus t. That's it. T of minus t is equal to f of minus t plus 4. So this is a natural procedure you can follow without any precaution. But if you want to go for the reverse fashion, first thing is time scaling. Then what I will do, z of t is equal to f of minus t I will do. Then now what you have to do, you have to replace t by t minus 4. If you replace t by t minus 4, minus of t minus 4 is equal to minus t plus 4, just minus t plus 4, f of minus t plus 4. So this is a time shifting. So this much amount of time shifting that you have to do for the signal z of t. So here basically if you see, here there is a signal, there is a minus of minus 4 means advance, right? Advance. So here we have to go for the delay. So z of t minus 4 means we have delay. Here it is advancing. So this is a point always you have to keep in your mind. So that is the reason I always recommend you to go for the natural way. Always I recommend you to go for the natural way, which is time shifting, then go for the time scaling. But if you want to do it in the reverse, you can do it. But still, you have to know the concept in which way that you have to do, that you need to keep in your mind. So these points always you have to keep in your mind. So I recommend you to always go for the time shifting, then go for the time scaling. I have already told you how to do the time shifting, and I have already told you how to do the time scaling also. I have already explained these concepts in a very, very detailed manner. So I no need to further explain regarding this concept. Now, the next point that we are going to discuss is to get a signal f of minus 80 or the signal f of t involving combination of the time scaling and time reversal operations. They can be performed in any order without any precaution. See, this is a very important thing. Basically, I have already told you. Suppose there is a signal f of t. Suppose there is a signal f of t. Let me give you. It is having an initial point. It is starting from time t0 and it is ending at t2, t1. Let me assume it is initial position and it is a final position. It is starting from t0 and it is ending at t1. Then f of minus 80 means I have already told you, divide by minus a. So divide by a minus a, here also divide by minus a. Then what you have to do? So this is now the signal will become for the signal f of minus 80. The initial point is divided by minus a and the final point is t1 by minus a. Same thing. This is the only concept. This is this statement you don't have to remember because I have already told you the concept, right? So divide by minus a. So therefore, what we are, this is now it will become the initial point and this will become the final position. So this point always you have to keep in your mind. So either you can do the time reversal first or time scaling first. You can do it in any fashion. Time scaling, then time reversal, then time scaling. This is a very, the general position. First to go for the time shifting, then time scaling. And the procedure. Just to follow that one blindly and don't think about anything. Then you are going to get the result that you really want. The next thing is, any signal having steps alone, it can be completely defined as the sum of the number of delayed u of t's with suitable coefficients. Here the delay of u of t indicates the instant when the step is to occur, and the coefficient represents the amount of step change required at the delay given to u of t. So this what I already told you. Suppose there is some signal, the signal is having only of steps. Then you can represent the signal only with the help of u of t with some delay of u of t. So wherever there is a sudden change, where you can use the u of t delayed version. And the question is that if the sudden rise means take that positive, sudden decay means take that negative. How much amount of rise, take it that positive coefficient. How much amount of decay, that take it as the coefficient with the negative sign. So this point I have already told you. So therefore, if you see any signal which is having only steps alone in it, then we can easily represent with the help of the delayed number of u of t's. So wherever there is a sudden change, there you have to use the u of t version, the delayed version, and the coefficient is nothing but if it's a rising means go for the positive value. How much amount of change, how much amount of rising means that value you have to keep it the coefficient with the positive. Suppose how much amount of it is decreasing down, means how much amount of it is decreasing, that value you have to keep it here with the negative. So these points always you have to keep in your mind. Any signal having steps alone in it can be completely defined as the sum of the number of delayed u of t's with the suitable coefficients, where the delay of the u of t indicates the instant where a step is to occur, and the coefficient represents the amount of step change required at the delay given to u of t. The next thing is u of t minus t0 indicates it stands from t0. Yes, u of t minus t0 is going to indicate it is going to start from t0. I have already told you this important point. See, u of t is there. Suppose u of t is there. U of t is going to start from, what is the initial position? It is going to start from 0. And what is the final position? It is end at infinity. Suppose u of t minus t naught. So you have to add t naught with the initial position as well as final position. So 0 plus t naught is equal to t naught and infinity plus t naught is equal to infinity. So now it is going to start from t naught and it is going to end to infinity. So this point I have already told you. So u of t minus t naught, it will start at t naught and it will end at infinity with a unit value. This one I have already told you so many number of times. So now the next point is, any signal which is made up of straight lines alone can be completely defined as a sum of the number of delayed r of t's with suitable coefficients, where the delay of r of t indicates the instant of time when the change in slope required, and the coefficient indicates the amount of change in slope required at the delay given time. So this one I've already told you so many number of times. This concept, suppose any signal which is made up of only straight lines, and then we can completely define, and then we can be completely defined with the sum of the number of delayed r of t's with suitable coefficients, where the delay of r of t indicates the instant where the change in slope is required, and the coefficient is going to indicate the amount of change in slope required at the delay given. So this point always you have to keep in your mind. So I already told you, suppose if some signal is there, that signal is having only straight lines, that we can represent with the help of the delayed value of r of t's. So wherever the change in slope is there you have to use the r of t with the delayed version, and its coefficient is nothing but how much amount of change in slope, that value we have to keep. Or I've already told you, so at that given point, how much amount of slope that we need to add, that slope we need to consider, or the amount of change in slope also, the final slope minus the initial slope. So those things also you have to take into consider. Only the change in slope is nothing but it's a coefficient, and wherever the change in slope is happened, there you have to use the delayed version of r of t. So a signal which is made up of straight lines alone can be completely defined as the sum of the number of delayed r of t's with the suitable coefficients, where the delay of r of t indicates the instant of time where the change in slope required, and the coefficient indicates the amount of change in the slope required at the delay given to. Actually, it is they indicate the amount of change in slope required at the delay given t naught. So that's, I think you have understood the point and what I'm trying to tell you. Suppose a signal is there which is made up of only straight lines, then we can represent with the help of delayed version of r of t's. So wherever there is a change in slope, there you have to use the delayed version of r of t, and its coefficient is nothing but the change in slope only, or the amount of slope that we need to add for the previous slope in order to get the next slope. So that the value we have to consider. So this point I have already told you. So the next point is, signals having steps alone in them, when it is defined in terms of u of t, the sum of coefficients will be 0 only when the signal has finite time duration. This is however not true for signals made up of straight lines defined in terms of r of t. See, I have already told you this point also. Suppose there is some signal which is made up of only steps. So you have represented the help of u of t's, and that signal is having a basically finite time duration signal. Then if you add the coefficients of the signal, then if you add the coefficients of the expression of f of t signal, the coefficient is going to give you 0. But this is not the true in the case of the straight line signal. Suppose if there is a signal which is having only of straight lines, and if you try to figure out with the help of r of t, you got the expression, and if you add this, it is also finite time duration signal, and if you add all the coefficients, that value is not equal to 0. So the sum of the coefficients is equal to 0 only for the step version, but not for the straight line version. So suppose I can say only one thing. Suppose if there is a signal a finite time duration signal in the steps version, then if you add all the coefficients, it is equal to 0. But in the ramp version, the straight line version, even though it is a finite time duration signal, if you define in terms of r of t, but if you add those coefficients, its value is not equal to 0. So signal having the steps alone in them, where it is defined in terms of u of t, the sum of coefficients will be 0 only when the signals have the finite time duration. This is however not true for signals made up of straight lines which are defined in terms of the r of t. So this point also I have already told you. So now the next thing is, which is to sustain f of t occurring for t greater than 0, multiply f of t with u of t. To sustain f of t occurring for t greater than 0, multiply f of t with u of t. Suppose if you want only f of t for t greater than 0, but not t less than 0, then you have to multiply f of t with u of t. So to sustain f of t occurring for t greater than 0, multiply f of t with u of t means, see, f of t signal is having from minus infinity to plus infinity. What I want only f of t of those percentages which is having from 0 to infinity means you have to multiply f of t with u of t. So whenever you are going to multiply f of t with u of t, I am going to get the signal f of t only from t is equal to 0 to infinity, but not from minus infinity to 0. So therefore, in order to sustain the f of t for occurring for t greater than 0, then you have to multiply f of t with u of t. Similarly, in order to sustain f of t occurring for t less than 0, then multiply f of t with u of minus t. So therefore, you can say, if you want to sustain the f of t occurring for t greater than 0, then you have to multiply f of t with u of t. Similarly, if you want to sustain the f of t occurring for t less than 0, then you have to multiply f of t with u of minus t. It's a very simple thing. So if you want the signal only for t greater than 0 means, you have to apply you have to multiply f of t with u of t. Suppose if you want a signal of f of t only for t less than 0 means, then you have to multiply f of t with u of minus t. So, in order to sustain the f of t occurring for t greater than 0, then you have to multiply f of t with u of t. In order to sustain the f of t occurring for t less than 0, then you have to multiply f of t with u of minus t. The next thing is, negative values of time are alone perfectly physically indicating past time instant of time. Negative values of time are alone perfectly physically indicating past time of past and instant of time. See, basically, whenever you go for the time domain, so whenever you go for time domain, I think you have seen there is a time, and it's a time domain. So this is a 0, this is a 1, this is a 2, and this is a negative 1, and this is a negative 2. So what is the meaning of negative values? These are the past time. This is the, suppose you are basically seeing the analysis from t is equal to 0. Means this is a past, and this is a future. So this is a future and this is a past. So negative values are going to indicate these are the past time, and the positive values are going to indicate the future time. So this is a point always you have to keep in mind. So negative values are basically they are going to indicate the past away instant of time, past away instant of time. So therefore we can say that the negative values of time are alone perfectly physically indicating these are the past away instant of time. So negative values of time are alone perfectly physically indicating past away instant of time. So therefore we can say simply what is the meaning of negative value of time? Negative value of time is simply these are the past away time. So negative value of time are alone perfectly physically indicating a past away instant of time. The next point is r of at. So r of t is nothing but t into u of t. So here let me write here. So let me write what is r of t. So let me write here. R of t is nothing but t into u of t, or simply you can write like this: r of t is equal to t for t greater than or equal to 0. It is equal to 0 for t less than 0. Right? You can write like this. Suppose if you want r of at, then what is the meaning here? So r of at is nothing but replace t by at. So it will become at. So for here also at greater than or equal to 0. What is the meaning of this one? T greater than or equal to 0. Similarly, it is equal to 0 for t less than 0. So simply here, at less than 0. So simply you are going to get t less than 0, right? T less than 0. See, I have replaced t by at, that's it. Wherever t is there, I replaced t by at. So this is what I have got. So the for r of at is nothing but at for t greater than or equal to 0, and is equal to 0 for t less than 0. As you can see clearly here. So what I can say, then what is the other thing? A into r of t. So what is the meaning of a into r of t? A into r of t is nothing but at for t greater than or equal to 0, and it is equal to 0. 0 into a is nothing but 0, right? So 0 for t less than 0. So we can say a into r of t is nothing but at for t greater than or equal to 0, and is equal to 0 for t less than 0. So now r of t is nothing but t for t greater than or equal to 0, and is equal to 0 for t less than 0. So then what we can see? Then what I can see? If you see clearly, these both are equal, right? So r of at is nothing but a into r of t. Here also at, here also at. For t greater than or equal to 0, for t greater than or equal to 0. It is equal to 0, it is equal to 0. For t less than 0, for t less than 0. So therefore, r of at is equal to a into r of t. So this is possible only for result library. R of at is equal to a into r of t. This is possible only for a greater than 0. Only for a greater than 0. So this is an important point always you have to keep in your mind. So r of at is always equal to a into r of t only for a greater than 0. only for a greater than 0. Why it is not possible for a less than 0 also I will discuss. So this point always you have to keep in your mind. So R of t is nothing but it is equal to t means it has a unit it has a unit slope, and R of a t means it has the slope of a. Here unit slope and here slope of a. So let me see here. So R of t is nothing but t greater than or equal to 0, and it is equal to 0 for t less than 0. So R of a t is nothing but wherever t is there, t plus 3 by at. So here at here also at greater than or equal to 0 means t greater than or equal to 0. Here 0 and at less than or equal to 0 means t less than 0. And you know a into R of t is nothing but multiplied by a here. It will become here 80, but here or equal to 0, it will become 0 for t less than 0. So if you are going to see these two things, we can say R of a is nothing but a into R of t, because here also 80, here also 80, here also t greater than equal to 0, here also t greater than equal to 0. Here it is 0, here also 0. Here t less than 0, here also t less than 0. So R of a is equal to a into R of t for a greater than 0. R of t is nothing but for t less than 0, its value is equal to 0, and for t greater than equal to 0, its value is equal to t means it has a straight line with a slope of 1. The t is equal to 1 means here also 1. R of a is nothing but for t less than 0, its value is equal to 0, and for t greater than equal to 0, its value is equal to 80 means it is a straight line passing through origin with the slope of a. The t is equal to 1 means its value is equal to a. So this is the graph of R of t and this is the graph of R of a. So this point always you have to keep in your mind. Now you will see for negative values of t, what is going to happen? Let us see now. So negative t, what is going to happen? So for R of minus t, R of minus t, what is the meaning of R of minus t? See, you know R of t graph, which is it is starting from t is equal to 0 and it is ending at t is equal to infinity, right? R of minus t means I have already told you. So here, what is the initial time? 0, and the final time is infinity. Initial starting position is 0 and the final position is infinity. R of minus t means divided by minus 1. So 0 minus 1 is nothing but 0 minus 1, and this is infinity minus 1, because R of minus t means you have to divide by minus 1. The initial and the final position 0 by minus 1 is 0, and the infinity by minus 1 is minus infinity. So therefore we are going to get a graph like this. So now the initial position is 0 and the final position is minus infinity. So this is the graph that we are going to get. So R of minus t is this is the graph that we are going to get. So this is at t is equal to 0 and this is t is equal to minus infinity. So like this you are going to get the graph R of minus t. So how we can write the expression R of minus t is equal to 0 for t greater than 0 and its value is equal to minus t for t less than or equal to 0. So you can see clearly here. So R of minus t is equal to 0 for t greater than 0 and its value is equal to minus t. Suppose if you substitute t is equal to minus 1, then what you are going to get? T is equal to minus 1 means we are going to get plus 1, right? So plus 1, right? So if you substitute t is equal to minus 1, what you should get? Then you should get plus 1, right? So therefore this we are going to get like this. So this is the expression that we are going to get. So R of minus t is equal to 0 for t greater than 0 and its value is equal to minus t for t less than or equal to 0. Then what I can say? So what is the slope here? The slope is equal to minus 1. So what is the slope here? Slope is equal to minus 1. Slope is equal to minus 1. Now what I can say? So now I already told you R of a t is equal to a into R of t. This is for a greater than 0. A greater than 0 means I can write like this: R of 70 is equal to 7 into R of t, because 7 is greater than 0. Now what is R of minus 70? R of minus 70 is not equal to minus 7 into R of t. So therefore this is in reality. So therefore R of minus 70 is not equal to minus 7 into R of t. See, R of t, you know what is R of t? See, R of t, you know what is R of t? I already told you. Minus 7 to R of t is nothing but what you are going to get? Like this we are going to get. So listen carefully. So R of minus 70 means like this you are going to get. Okay, like this you are going to get. So suppose this is R of t, R of minus 70. See, minus 7 into R of t. Suppose if you substitute t is equal to 1, then what you are going to get? Then you should get minus 7. Then you should get minus 7. So this is minus 7 to R of t. But R of minus 70 is nothing but what you are going to get? R of minus 70 is equal to 0, but t greater than 0, and here it will become minus 70. Hence replace t by 70. You are going to get t less than or equal to 0. So what you are going to get? The graph that you are going to get is like this one. with a slope of minus 7. So this is the slope we are going to get with a slope of minus 7. Slope of minus 7 we are going to get. So you can see clearly here. So this is the R of minus 7 P. So both are different, right? This graph and this graph both are different, not same. Both are different. That is the reason you can say R of minus 7 is not equal to minus 7 into R of T. So R of T is like this one. Minus 7 is come downward. So therefore R of minus 70 is not equal to minus 7 to R of T. That is the reason R of A is equal to A into R of T. This equation is going to be valid only for A greater than 0. So finally I am trying to tell you which is R of A into T is R of A into T is always equal to A into R of T. This expression is going to get valid only for positive value of A, means A greater than 0. So this point I have already told you. See for negative values of A, why this is not holding means I have already explained with a clear cut example also I have given you. So that is the reason R of 70 is equal to 7 to R of T and R of minus 70 is not equal to minus 7 to R of T. So therefore R of A into T is equal to A into R of T. This expression is valid for only for the positive values of A. So this one I have already told you. R of minus 10 means it has a negative slope here and here it is 0. This point I have already told you. So now the next thing is delta of T can be obtained from so many parental signals under A tends to 0. Delta of T is also called as the generalized function. What is true for other signals may be true or false for delta of T and vice versa. See, delta of T can be obtained from so many parental signals under A tends to 0. See, I already told you this concept, right? Delta of T we are going to get from so many parental signals when A tends to 0. For all those parental signals, if you make the limit A tends to 0, then we are going to get the delta of T. So delta of T can be obtained from so many parental signals under A tends to 0. Delta of T is also called as generalized function. So what is true for other signals may be true or false for the delta of T and vice versa. So what is true for other signals, it may be true or it may be false for delta of T and vice versa also. So therefore, what we can say, suppose some rule is true for other signals. That rule may be true or it may be false for delta of T. Vice versa also. Whatever is true for delta of T, that it can be true for the other signals or it may be false for the other signals also. So therefore, we can say delta of T can be obtained from so many parental signals under A tends to 0. So that is the reason delta of T is also called as generalized function, because we are going to get the signal from so many parental signals under the limit A tends to 0. So whatever the true for the other signals, it may be true or it may be false for delta of T and vice versa is also true. So finally, I can say delta of T signal which we have obtained from so many parental signals under the limit A tends to 0. So that is the reason delta of T is also called as the generalized function. So whatever the things which are true for other signals, for the parental signals, it may be true or it may be false for delta of T and vice versa also. So that is the reason I use so many parental signals and I use the limit A tends to 0, then I have got the delta of T. That is the reason delta of T is also called a generalized function. So whatever it is true for the other signals, it may be true or it may be false for the delta of T and vice versa. So finally, delta of T can be obtained from so many parental signals under the limit A tends to 0, and delta of T is also called as the generalized function. So what is true for the other signals, it may be true or it may be false for delta of T and vice versa. The next thing is, delta of T is not like other normal signals. It doesn't have a unique definition. Its definition is only generalized by using wide variety of signals having inversely proportional width and height. Hence, delta of T is also called a generalized function. As delta of T is not like other normal signals, what is true for other normal signals may sometimes become false for impulse signal and vice versa. Here I will explain in a detailed manner, which is delta of T is not like other normal signals. It doesn't have a unique definition. Its definition is only generalized by using wide variety of signals having inversely proportional width and height. Hence, delta of T also called as the generalized function. As delta of T is not like other normal signals, what is true for other normal signals may sometimes become false for impulse signal and vice versa. So basically, I have already told you, basically I have taken a lot of parental signals. So I have taken a lot of signals, right? I have taken a lot of signals and I have made the limit A tends to 0. because their width and height are inversely proportional because the area is equal to unity. So if I make a tends to 0, then default I am going to get the impulse signal. So that is the reason delta of t is not like any other normal signals. It doesn't have a unique definition. Its definition is only generalized by using the wide variety of signals having inversely width and height. As delta of t is also called as generalized function, as delta of t is not like any other normal signals. What is true for other normal signals may sometimes become false for the impulse signal and vice versa. So in simple words I can say, basically I have taken a lot of general signals. Their width and height are inversely proportional, so therefore their area is equal to unity. So if I make the limit it to 0, then I am going to get the delta of t. So delta of t you can define from any of the signals. Any of the signals you can define. That is the reason delta of t is not a normal signal, because it can define from any other signal with a height and a width with a inversely proportional to each other. So that is the reason whatever the things are true for normal signals, it may be true or it may be false for the impulse signal, and vice versa is also true. So this delta of t is not like other signals. So whatever the things which are true for other signals, it may be true or it may be false for the impulse signal. So this point always you have to keep in your mind. So finally I can say the delta of t is not like other normal signals. It doesn't have a unique definition. Its definition is only generalized by using a wide variety of signals having inversely proportional width and height. And hence delta of t is also called as generalized function. As delta of t is not like other normal signals, so what is true for other normal signals may sometimes become false for impulse signal and vice versa. So finally I can say, see, delta of t is not like a general signal. See, like a normal signals, it is not like normal signals, because we can define this by any signal which is having a width and area, width and height of inverse proportional. So the area is equal to 1. So if you try to make the limit equals to 0, then we are going to get delta of t. So we can define from any signal which is having a inverse proportion of width and height. So because of this reason only, we can say whatever the things are true for normal signals, it may be true or it may be false for the impulse signal, and vice versa is also true. So these points always you have to keep in your mind. Now we are going to discuss the next point, which is integration of -7 to +7 a into delta of t is equal to a, because I already told you here you should keep dt also. Here you should keep here dt into dt. So we can say integration of -7 to +7 a into delta of t dt, because there is a constant we can take it outside the integration. So a into integration of t is equal to -7 to +7 delta of t dt is nothing but area under the impulse function is equal to 1. So a into 1 is equal to a. So here you are going to get a is a scalar. Always tells area of the impulse or strength of the impulse. So basically it is nothing but scalar. It's always going to tell you area under the impulse or the strength of the impulse. A is nothing but basically it is going to tell you the area under the impulse or the strength of the impulse. A is nothing but basically it is going to tell you the area under this impulse. A into delta of t dt is nothing but for this function the area under the function delta of t dt is nothing but it is called, we can say this A. So A is the scalar. It always tells the area of the impulse or the strength of the impulse. The next point is integration of t is equal to -7 to +7 delta of bt. Delta of bt, because I've already told you one important formula. What is the important formula? Which is delta of at is equal to 1 by mod a into delta of t. So this one I've already told you. Delta of at is equal to 1 by mod a into delta of t. Then what is the area? So what is the area we can say? The area is nothing but integration of -7 to +7 delta of at dt. So we can replace like this type. So delta of at I can replace 1 by mod a. So 1 by mod a is a constant, we can take it outside the integration into integration of t is equal to -7 to +7 delta of t dt. So this is equal to 1, right? So 1 into 1 by mod a is nothing but 1 by mod a. So this is what we are going to get finally. Then basically they have used here b. So of here they have used b. The concept is same, right? So this formula always you have to remember, which is delta of at is equal to 1 by mod a delta of t. Here a is a can be the positive or a can be negative. A can be positive or a can be negative. I already told you, right? Here a can be either positive or a can be also negative. So this formula, as I already told you so many number of times. So now the next thing is integration of t is equal to -7 to +7 delta of t minus t naught. Basically, what you have did, just have shift the impulse function by t naught. So still the area will be same. So therefore area is nothing but 1. Similarly, integration of t is equal to minus 70% delta of minus t. What is delta of t? Impulse function. Delta of minus t is also impulse function. Before we say, and we can say mirror image. So still the area is equal to unity. Still the area is equal to unity. If you want to use the formula delta of AT, which is equal to 1 by mod n delta of t, area is equal to minus 1. So 1 by minus 1 is 1 by mod of minus 1 is equal to 1 by 1. So answer you are going to get still 1. Here you can use this formula also. Here P is nothing but minus 1. So 1 by minus 1 mod is nothing but 1 we are going to get. Even you can use this formula to get this result. But always remember, delta of AT is equal to 1 by mod A into delta of T. And area under the impulse function is equal to 1. So now, the next important point is f of t delta of t. So f of t delta of t means whenever for any function f of t, if you are going to multiply with delta of t, then you are going to get the impulse function with a area of f of 0. So f of 0 into delta of t, we can say f of t into delta of t is nothing but f of 0 into delta of t because it is good. So whenever you are going to multiply f of t and delta of t, the overall the net result is going to take only the sample at t is equal to 0, which is f of 0 only you are going to get. So f of 0 into delta of t, it is also impulse function. F of t into delta of t minus a is nothing but f of a into delta of t minus a. So whenever you are going to multiply f of t with delta of t minus a, shift the first of impulse function. Again it is going to take the sample at a at t is equal to a. So f of a into delta of t minus a, it is also a sample. It is also a sample. It is f of a in delta of t minus a. So therefore f of t in delta of t is equal to f of 0 in delta of t. F of t into delta of t minus a is nothing but f of a into delta of t minus a. Basically, here the sample is present at t is equal to a. So at the sample we are going to take the function f of t, means it is going to take the only sample at t is equal to a. So therefore, f of a into delta of t minus a. So f of t into delta of t is equal to f of 0 into delta of t. F of t into delta of t minus a is equal to f of a into delta of t minus a. Very simple thing, I don't need to further explain. So basically I have already told you. Step C, I have already told you one important thing. These things always you have to keep in your mind. The relation between them, this is the delta of t, this is the u of t, then r of t, then parabola. So for this, let's go for this one. So what is the, see, this is a u of t. So u of t is the, u of, see, basically, integration of delta of t is nothing but, see, let me write this one. So how you can say, if you do differentiation like this, the differentiation of r of t, you are going to get u of t. The differentiation of u of t, you are going to get delta of t. So this is the way you should go for the differentiation. Suppose if you want integration, means you have to go in this direction. Integration. So integration. So integration of delta of t means u of t. Integration of u of t means r of t. So integration of delta of t means u of t. Integration of u of t means r of t. Similarly, differentiation of r of t means u of t. Differentiation of u of t means delta of t. So these ones always you have to keep in your mind. So therefore, u of t is equal to d by dt of r of t. And similarly, so this one we have discussed, right? So u of t is equal to d by dt of r of t. Similarly, delta of t is equal to d by dt of u of t. So therefore we can say u of t is equal to d by dt of r of t and delta of t is equal to d by dt of u of t. Similarly, if you want to write in the integration format, then u of t is equal to integration of impulse signal. So u of t is the integration of the impulse signal. U of t is equal to integration of t is equal to minus m to t delta of tau into dt. Similarly, r of t is the integration of u of t. So r of t is equal to integration of minus m to t u of tau d tau. So therefore you can say u of t is the differentiation of r of t and delta of t is the differentiation of u of t. Similarly, u of t is the integration of delta of t. R of t is the integration of u of t. So let me write here. You can write. So therefore you can say u of t is the d by dt of r of t. Sorry, u of t is the d by dt of r of t, and delta of t is equal to d by dt of u of t. Similarly, u of t is the integration. This tau is equal to minus into t delta of tau d tau. Similarly, r of t is the integration of the integration of tau is equal to minus into t u of tau d tau. So these ones always you have to keep in mind. So u of t is the differentiation of delta of t. Sorry, u of t is the differentiation of r of t and delta of t is the differentiation of u of t. Similarly, u of t is the integration of delta of t R of t is a integration of the u of t. So this is what I have discussed here. The next thing is derivative of steps consists of impulses wherever steps are occurring and the impulse area is equal to the step size. So listen carefully. Derivative of steps consists of impulses wherever steps are occurring and the impulse area is equal to the step size. So basically, derivative of steps consists of impulses wherever steps are occurring and the impulse area is equal to the step size. I have already told you, suppose if you are going the average steps, so derivative of steps means at a constant value is equal to 0, but the way there is a sudden rise. Sudden rise means impulse is positive area. Sudden decay means impulse of negative area. Whatever that rise is nothing but that positive rise, then that is the area. Sudden decay, the amount of decay, sudden decay, that is the negative area. So this is what I am trying to tell you. So therefore, if we have steps, the derivative of steps is equal to 0, but when there is sudden rise and sudden decay, at the sudden rise and sudden decay, you are going to have the impulses. At the distance, you are going to get the impulses. If the unit step is increasing, means the impulse is a positive area. If the unit step is there, the sudden decay means the impulse of negative area. The area is nothing but that corresponding coefficient of rise, and negative area is nothing but the amount of sudden decay. If you want some example, I can give a small example also. Let me take here. Suppose, let me take a rough example. So let me take a rough example like this. So this is at t is equal to 0. This is at t is equal to 1. And this is at t is equal to 2. Let me take this at t is equal to 2. This value is of 2. This value is of 5. And this value is of -7. Let me consider like this. Then what is the derivative of this one? So what you are going to get here, there will be some impulse. So what is this impulse area? This impulse area, how much it is rising? From 0 to +2 it is rising. So +2 is the area. Here also it is rising, right? It is rising. How much amount of riding? From 2 to 5 means 3 is rising. So here there will be +3. But here, this is at t is equal to 0, this is at t is equal to 1. Suppose here, if you see clearly, this is at t is equal to 2. But t is equal to 2, there is a sudden decay. How much it is decaying? Here, from here it is a 5. Here it is a 5. Here it is 7. So 7 plus 5 is nothing but 7, 8, 9, 10, 11, 12. So as it is decaying, right? So it will be negative like this. The area is of -12. So this is what you are going to get. So for this unit step signal, you are going to get derivative of the signal. You are going to get like this. So whenever there is a steps, then you are going to get the impulses. So sudden rise, how much it is rise? +2. So take a +2 area. Sudden rise by how much? +3. So take here +3. Sudden decay by how much? Here this is 5, this is 7. So total 12. So sudden decay by -12. So -12. Rise means positive, decay means negative. That's it. So this is the impulse area we are going to get. So wherever the steps are coming, instance of steps are coming, there you have to take the impulse. Those area is nothing but the amount of sudden rise. That's it. So derivative of steps consists of impulses wherever steps are occurring and the impulse area is equal to the step size. That's it. Integrals of impulse consists of steps wherever impulses are occurring and the step size is equal to the impulse area. So integral of the impulse consists of steps wherever impulses are occurring and the step size will be equal to impulse area. Suppose if you are doing the reverse. Suppose if you are doing the integration of the impulse means we are going to get the steps. So whatever the area is nothing but it will tell you if it's a positive means you have to go for the rise of this much. If it is a negative means you have to go for decay. So listen carefully here. Suppose I want to do the integration of this one. Suppose if I want to do the integration of this one, then I should get the previous graph, right? How you are going to get is see here. So up to here it is 0. The area is +2. +2 means rise by +2. So this is a +2. It is rise by +2 means this will be 2. Again +3 we got. This rise by again +3. So it will be 5. Right? Up to here it is here. Again then decay by -12. So decrease by -12. So this will be -7. That's it. So therefore we can say that this is a so this is the derivative of this one and this is the integration of this one. Same thing we are going to get right? So +2 means you have rise by +2. +3 means again rise by +3. Then -12 means you have decay by -12. That's it. So this is the graph that you are going to get. So integration of impulses nothing but steps you are going to get. And whatever this area is nothing but you have to rise by this much. Plus means rise, minus means decay. That's it. So this point always you have to keep in your mind here. So now the next point is, what is the next point here? F of t is equal to 70 is the real value signal. Why? Because there is no complex value j, there is no complex term. That is the reason it is called the real value signal. Suppose f of t is equal to 70 plus 70 plus j 18t. It is called a complex value signal because there is a complex term. Very simple, right? See, in the signal f of t, there is no complex term, so it is called a real value signal. Suppose in the signal there is a complex term j, complex variable j, so it is called as a complex value signal. That's it. Very simple, right? So therefore, you can have signals either of real signal or complex signal. Real signal means there is no imaginary part. Complex value signal means there is an imaginary part. This is a very small difference. So real value signal means there is no imaginary part. Complex value signal means there is an imaginary part. So you can see clearly in this signal there is no imaginary part. So that is the reason it is called as a real value signal. In this signal there is a imaginary part. So that is the reason it is called as the complex value signal. So now let's go for the next point. Signals are of two types, continuous time signals and discrete time signals. So basically, signals are of two types. One is the continuous time signal and the other is the discrete time signal. Continuous time signal means f of t, means it is defined at each and every value of t, means from -7 to +7, even at any value 0.001 also it is defined. Discrete time signals means it is defined only at integers. Here t is a real value. Here t is a real value. Real value means it can take any value. It can take any value. Even fractions also it can take. Where n is only integers. Integers means 0, plus or minus 1, plus or minus 2. So therefore, we can say signals are of two types. One is a continuous time signal and a discrete time signal. Continuous time signal is f of t. Discrete time signal means f of n. So continuous time signal means here t is a real value. Means it can take any value. Discrete time signal means f of n. Where n is the integers. Means 0, plus or minus 1, plus or minus 2. Only integer values only is going to be considered. So in this subject, discrete time signals derived from the continuous time signal by assume Ts is equal to 1. So basically, in the subject, discrete time signals we are going to derive from the continuous time signal by assuming Ts is equal to 1. What is the meaning of this one? Suppose there is a continuous time signal. From that we are going to sample with a time period of 1. If we are going to sample a time period of 1, then what we are going to get? Then we are going to get the discrete time signal. So for each and every second, if we are going to get sample, then we are going to get the discrete time signal. So what are the discrete time signals that we are going to get from the continuous time signal by the sampling process? So therefore, what are the discrete time signal that we are going to discuss in this course are the sampled version of the continuous time signal for Ts is equal to 1. For Ts is equal to 1. So with the sampling period of 1, we are going to sample the continuous time signal, and we are going to get the discrete time signal. So in this subject, discrete time signals we are going to derive from the continuous time signals by assuming Ts is equal to 1 second. So finally I can say, in the subject, what are the discrete time signals that we are going to study? Those are basically derived from the continuous time signal by assuming the sampling period Ts is equal to 1. So suppose some continuous time signal is there, that we are going to sample the signal with the help of sampling signal of Ts is equal to 1. Then we are going to get the new signal that is nothing but discrete time signal. So t is a real number. I have already told real number means it can take any value. 0.001 minus 0.001. N is always an integers. I have already told you t is a real value and n is an integers. Integers means 0 plus or minus 1 plus or minus 2 plus or minus 3. But t is a real value. It can take any value. Always digital signal processing is easier than the analog signal processing. So this is a very important thing. See, always digital signal processing is always easier than the analog signal processing. This point I have already told you so many number of times. So that is the reason always we go for the digital signal processing rather than analog signal processing, because the processing of digital signaling is very easier when compared to analog signal processing. So therefore, we can say the digital signal processing is always easier when compared to analog signal processing. That is the reason there are a lot of digital systems. Always digital signal processing is always easier than the analog signal processing. So always digital signal processing is always easier than the analog signal processing. So this point always you have to keep in your mind. So therefore we can say always the digital signal processing is always easier than the analog signal processing. That is the reason digital systems are used in a large amount of manner when compared to analog systems. So as that digital signal processing is easier when compared to analog signal processing, because of this reason only we can say that decision systems are used in larger quantity than when compared to analog systems. The next point is, in discrete time signal, always natural process shifting followed by scaling is followed but not reverse. In discrete time signal, always natural process shifting followed by scaling is followed but not reverse. See, I've already told you, see, in the continuous time domain and the discrete time domain always go for the only one thing, natural procedure. I recommend you to go only for the natural procedure, which is first shifting, then go for the scaling. So in discrete time signal, always natural process shifting is followed. Shifting is followed by scaling. So natural process is followed, which is shifting but followed by scaling, but not the reverse. So I recommend you to, whether it's a continuous time signal or the discrete time signal, I want you to follow only the natural process, which is first go for the shifting, then go for the time scaling. Now the next thing is, so what is U of n? U of n is a discrete time signal. So U of n is equal to 1 for n greater than or equal to 0, and its value is equal to 0 for n less than 0. So this is called a discrete time unit step signal. So U of n is equal to 1 for n greater than or equal to 0, and its value is equal to 0 for n less than 0. So this is called as the discrete time unit step signal. So U of n is equal to 1 for n greater than or equal to 0, and its value is equal to 0 for n less than 0. So this is called as the discrete time unit step signal. Delta of n is equal to 1 for n is equal to 0, and its value is equal to 0 for n not equal to 0. So this is called a discrete time unit impulse signal. So delta of n is equal to 1 for n is equal to 0, and its value is not equal to, it is equal to 0 for n not equal to 0. So this is called discrete time unit impulse signal. So delta of n is equal to 1 for n is equal to 0, and it is equal to 0 for n not equal to 0. So this is called discrete time unit impulse signal. So delta of n is always equal to delta of n, whether a is positive or a is negative. So delta of n is always equal to delta of n, whether a is positive or a is negative. So here let me give you some important point. See what I have told you in a continuous time case. What I have told you in a continuous time case, I have told you one important point, which is delta of AT is equal to 1 by mod A into delta of T, where A can be positive or A can be negative. Similarly, delta of AN is always equal to delta of N only, where A can be positive or A can be negative. So this is an important thing always you have to keep in mind. So we can say delta of AT is equal to 1 by mod A into delta of T, where A can be positive or A can be negative. But delta of N is always equal to delta of N, where A can be positive or A can be negative. So this is the point always you have to see. Why it is like this? Suppose if you ask me why it is like this, then I can tell you. Suppose you take P of N is equal to delta of AN, right? Suppose I want P of 0. P of 0 is delta of A into 0 is nothing but 0. Delta of 0 you know 1. So P of 1 I want, which is equal to delta of A into 1 is equal to A. Delta of A is nothing but simply we can say 0. Similarly, P of minus 1, I want delta of minus A, which is also equal to 0. So therefore, we can say finally, P of N is nothing but which is delta of N. So therefore, delta of An is equal to delta of N. That is the reason I have shown you here. I given the proof also. But I want to remember this concept is delta of AT is equal to 1 by mod A into delta of T, for A can be positive or A can be negative. But in the discrete time domain, delta of N is equal to delta of A, delta of N only, where A can be positive or negative. So this is for the continuous time domain and this is for the discrete time domain. So these two formulas always you have to keep in your mind. Delta of AT is equal to 1 by mod A into delta of T, where A can be positive or A can be negative, and delta of N is equal to delta of N, where A can be positive or A can be negative. So these point always you have to keep in your mind. The next point is step. This is a ramp signal. The discrete time ramp signal. R of n is equal to n for n is not equal to 0, and it is equal to 0 for n less than 0. So this is called as the discrete time unit ramp signal. Discrete time unit ramp signal. So these things always you have to keep in your mind. So R of n is equal to n for n is not equal to 0, and its value is equal to 0 for n less than 0. So this is called as the unit ramp signal. Discrete time unit ramp signal. So finally, U of n is equal to 1 for n is not equal to 0, and is equal to 0 for n less than 0. So this is called discrete time unit step signal. And delta of n is equal to 1 for n is equal to 0, and its value is equal to 0 for n not equal to 0. This is called as discrete time unit impulse signal. And R of n is equal to n for n is not equal to 0, and its value is equal to 0 for n less than 0. So this is called a discrete time unit ramp signal. And delta of AT is equal to 1 by mod A and delta of T, where A can be positive or negative, and delta of N is equal to delta of N, A can be positive, A can be negative. So these things always you have to keep in your mind. Now we are going to discuss the next one, which is R of n is equal to U of n minus U of n minus 1. I've already told you, which is, sorry, delta of n. Delta of n is equal to U of n minus U of n minus 1. So delta of n is nothing but, which is U of n minus U of n minus 1. So delta of n is nothing but U of n minus U of n minus 1. But if you want to write in terms of time domain, what's the expression that you will write? Here I've already told you how to write the time domain expression, which is delta of t is equal to d by dt of u of t. Right? Delta of t is equal to d by dt of u of t. This is a time domain expression. But if you want discrete time expression means delta of n is equal to u of n minus u of n minus 1. So this one always you have to keep in your mind. So this is a continuous time relation and this is a discrete time relation. So delta of t is equal to d by dt of u of t, and this delta of n is equal to u of n minus u of n minus 1. Then R of n is equal to sigma k is equal to 1 to infinity u of n minus k. So this is the relation between R of n and u of n. It's a discrete time domain. But if you want to write in terms of continuous time domain, how you are going to write, which is R of t is equal to integration of tau is equal to minus infinity to t u of tau into d tau. So this is a continuous time representation and this is a discrete time representation, which is R of n is equal to sigma k is equal to 1 to infinity u of n minus k. So this is the continuous time representation and this is a discrete time representation. So R of n is equal to sigma k is equal to 1 to infinity u of n minus k. So these two things always you have to keep in your mind. So this is a continuous time relation and this is a discrete time relation. Delta of n is equal to u of n minus u of n minus 1, and R of n is equal to sigma k is equal to 1 to infinity u of n minus k. So f of n into u of minus n means for n greater than 0, all are 0. So f of n into u of minus n is nothing but for n greater than 0, all these values are equal to 0. F of n into u of n for n less than 0, all values are 0. Because suppose for f of n, if you want only the signal for n greater than or equal to 0, then you have to multiply by u of n. Suppose for f of n, if you want the signal only for t less than or equal to 0, then you have to multiply by u of minus n. So listen carefully. For f of n, if you want the signal only for n greater than or equal to 0, means you have to multiply by u of n. So for f of n, if you want only the signal for n less than or equal to 0, means you have to multiply by u of minus n. These things same as the continuous time domain. So this is called as the u of minus n minus 1. So this is the signal representation of u of minus n minus 1. So let me tell you why it is like this. Suppose u of n, for u of n, the signal is going to start from 0 and it goes up to infinity. So signal is going to start from 0. Means the initial point is 0 and the final point is infinity. Similarly, for u of n minus 1, means you have to add plus 1 for 0 and infinity. So 0 plus 1 is 1 and infinity plus 1 is equal to infinity only. So u of n minus 1 is going to start from 1 and it goes up to infinity. Then first you did the shifting rate, then you have to do this time scaling. So u of minus 1 means you have to divide by minus 1 for the both things. 1 by minus 1 is minus 1, infinity by minus 1 is minus infinity. So the signal is going to start from minus 1 and it goes up to minus infinity. So the signal is going to start from minus 1 and it goes up to minus infinity with the value of 1. So this is a signal that you are going to get. Just we follow the rule, just time shifting, then time scaling. We follow the basic rule. Then we have drawn the graph. It is going to start from minus 1 and it goes up to minus infinity with the value of 1. So this is the graph that you are going to get. Then u of n is nothing but sigma k is equal to 0 to infinity delta of n minus k, or you can write sigma k is equal to minus n to n delta of k. You can write in different ways. See, if you want the continuous time representation, means u of t is equal to integration of delta of tau d tau, right? So tau is equal to minus infinity to tau is equal to t. So this is a continuous time representation, and this time representation means u of n is equal to sigma k is equal to 0 to infinity delta of n minus k, or sigma k is equal to minus n to n delta of k. So this is basically in this format. So if you see clearly, these both are in the same format. Integration is replaced by sigma and tau is replaced by k. That's it. So we are going to get this thing, right? Here integration are replaced by sigma and tau are replaced by k. That's it. So, or you can write like this also. U of n is equal to sigma k is equal to 0 to infinity delta of n minus k. Yes, it's a delayed impulse. Delayed impulse you can write, because u of n you can write delta of n plus delta of n minus 1 plus delta of n minus 2, up to goes on. So simply we can say sigma k is equal to 0 to infinity delta of n minus k you can write, right? Because u of n you can write delta of n plus delta of n minus 1 plus delta of n minus 2 and goes on. So simply we can write u of n is equal to sigma k is equal to 0 to infinity u of delta of n minus k you can write. And this is same as this fashion like integration, right? Integration is written by sigma and k, 2 is replaced by k and t is replaced by n. That's it. So you are going to get this one. Similarly now r of n is equal to sigma k is equal to 0 to infinity k into delta of n minus k. Because you know simply r of n, how you can write r of n, you can write like this: 0 into delta of n plus 1 into delta of n plus 2 into delta of. So you can write like this, right? Let me write here. So let me write this point. So let me write this point. R of n, how you can write r of n, you can write like this, right? 0 into delta of n plus 1 into delta of n minus 1 plus 2 into delta of n minus 2, and it goes on. So what you can write now? Simply what you can write? Simply you can write like this: sigma k is equal to 0 to infinity k into delta of n minus k you can write, right? Suppose if k is equal to 0, then what you are going to get? 0 into delta of n. Simply if k is equal to 1 means 1 into delta of n minus 1. K is equal to 2 means 2 into delta of n minus 2. Same thing we are going to get, right? So you can get r of n as 0 in delta of n plus 1 in delta of n minus 1 plus 2 in delta of n minus 2, and it goes on. So simply we can get r of n as sigma k is equal to 0 to infinity k in delta of n minus k. So this you can write, right? So this is the point you have to keep in your mind. So now the next point is, what is the next point? The next point is u of n is equal to sigma k is equal to minus infinity to n delta of k. Same thing, right? Same thing. This only I have written again. So u of n is equal to sigma k is equal to minus infinity to n delta of k. This is the continuous time representation and this is the discrete time representation. So replace integration by sigma 2 by k and t by n. That's it. The next thing is, what is the next thing? U of n is equal to r of n plus 1 minus r of n. So see, suppose you know this formula, right? U of t is equal to, you can write d by dt of r of t. You can write like this in a continuous time domain. But if you want the discrete time domain means u of n is equal to r of n plus 1 minus r of n. So this point always you have to keep in your mind. So u of t is equal to d by dt of r of t. So therefore u of n is equal to r of n plus 1 minus r of n. Same thing, we also same thing, right? So you can say delta of t is equal to d by dt of u of t. So delta of n is equal to u of n minus u of n minus 1. Here it is r of n plus 1 minus r of n here. So this is the point you have to keep in your mind. So u of n is equal to r of n plus 1 minus r of n. Here u of t is equal to d by dt of r of t. Then r of n, how we can write r of n? We can write like this: r of n. And what is reverse? What is the reverse thing? What is the reverse thing? Reverse is the integration, right? So r of t is nothing but integration of r2 is equal to minus infinity to t u of tau d2. You can write like this. So this is the continuous time representation. Discrete time representation means replace t by n, integration by sigma, and 2 by k. So what you are going to get? So therefore r of n is equal to sigma k is equal to minus infinity to n minus 1 u of k. So this is, you can see both are same, right? I will replace integration by sigma 2 by k. Then what you are going to get here, it is n minus 1 up to n minus 1 and t by n minus 1 we have k up to n minus 1. Why it is like this? Because if you substitute n is equal to 0, then it will go up to from minus n to minus 1 only it will go. Then definitely its value is equal to 0. Because at r of 0, its value should be equal to 0. So in that case, you have to go only from minus n to minus 1. Suppose r of 1 you want, r of 1 is nothing but 1 you should get. So if you substitute here, then 1 minus 1 is 0. So we are going from minus n to 0. But you know, u of 0 is equal to 1. So that is the reason we have to go up to n minus 1. And this is very simple. So r of n, you can write like this: sigma k is equal to 1 to infinity u of n minus k. You can write. So you can write like this: r of n is equal to sigma k is equal to 1 to infinity u of n minus k. Because it is basically a, and we can say that simply we can say that we can write like this: r of n is nothing but u of n minus 1 plus u of n minus 2 plus u of n minus 3 and goes on. So that is the reason. Let me write here. So we can write r of n like this also we can write. So we can write r of n like this also we can write: sigma, say u of n minus 1 plus u of n minus 2 plus u of n minus 3 also we can write like this. So if you write like simply, it goes up to infinity. So we can write sigma k is equal to 1 to infinity u of n minus k. So this is the r of n you are going to get. So r of n is equal to sigma k is equal to 1 to infinity u of n minus k. So this is what that we are going to get. So this is what we are going to get. So these are the different ways of writing. So finally, let me give you a summary. So let me give you a summary so that you can easily able to understand what I am trying to tell you. So here I will write the continuous time domain and here I will write the discrete time domain. So let me give the conclusion. So now if you see clearly that here continuous time. So delta of t is nothing but d by dt of u of t, right? Similarly here delta of n is equal to u of n minus u of n minus 1, right? Now what I can say? Now the next thing is u of t is equal to integration of delta of t dt. So tau is equal to, so t is equal to, you can say, so tau is equal to minus e2, it is tau here, tau is equal to minus infinity to t. So what I can write here? U of n is equal to, simply u of n is nothing but simply we can write like this, sigma k is equal to minus infinity to n delta of k, right? Delta of k, because minus infinity to n delta of k. So now in another fashion, so this we can write in the other fashion also. What is the other fashion we can write? Which is equal to, I have already told you, u of n you can also write which is delta of n plus delta of n minus 1 plus delta of n minus 2 plus delta of n minus 3. So u of n you can write delta of n plus delta of n minus 1 plus delta of n minus 2 and goes on. So simply we can write sigma k is equal to 0 to infinity delta of n minus k also you can write. I have already told you, because u of n you can write delta of n plus delta of n minus 1 plus delta of n minus 2 and goes on. So simply if you write like this, finally you are going to get sigma k is equal to 0 to infinity delta of n minus k, right? You are going to get like this. So now next what thing is, u of t I can write like this. U of t is nothing but d by dt of r of t I can write, d by dt of r of t. But in a discrete time domain, how we are going to write, which is u of n is equal to r of n plus 1 minus r of n. This one I have already told you. And then what is the reverse thing? R of t is the integration. Tau is equal to minus infinity to t u of tau d tau. So this how you can write here? R of n. So R of n, I have already told you. R of n you can write like this. Integration means sigma. Here tau is equal to k minus infinity. Here t is nothing but n minus 1 into u of k. Or you can also write R of n, I have already told you. How you can write u of n minus 1 plus u of n minus 2 plus u of n minus 3 and goes on. Then you can write like this, right? Sigma k is equal to 1 to infinity u of n minus k. So you can see finally this you can write u of n minus 1 plus u of n minus 2 plus u of n minus 3 and goes on. So simply you can write sigma k is equal to 1 to infinity u of n minus k you are going to get, as you can see clearly from this picture. As you can see clearly from this picture. And this one also you can write in terms of delta of k. Delta of k also you can write. How you can write? Simply I can write like this, which is r 0 into delta of n plus 1 into delta of n minus 1 plus 2 into delta of n minus 2 plus 3 into delta of n minus 3. So if you simplify, then you are going to get sigma k is equal to 0 to infinity k into delta of n minus k. So like this also you can write. So these are the different ways of writing. So all these things always you have to keep in your mind. So I have given the total summary also. So delta of t is equal to d by dt of u of t. So delta of n is equal to u of n minus u of n minus 1. Here u of t is equal to integration from 2 is equal to minus infinity t. Delta of tau d tau. So here u of n is equal to sigma k is equal to minus infinity delta of k, or sigma k is equal to 0 to infinity delta of n minus k. Here u of t is equal to d by dt of r of t. Here u of n is equal to r of n plus 1 minus r of n. Here r of t is equal to integration of tau is equal to minus infinity u of tau d tau. Here r of n is equal to sigma k is equal to minus infinity n minus 1 u of k, or sigma k is equal to 1 to infinity u of n minus k, or sigma k is equal to 0 to infinity k into delta of n minus k. I have already explained the in detail concept regarding this also I have told you. So these things always you have to keep in your mind. The next thing is the examples of the even signal. What is the meaning of even signal? Even signal is nothing but a signal which is going to satisfy f of minus t is equal to f of t. Then that signal is called as the even signal. The best examples are cos t. Cos t is an even signal, and delta of t is also even signal. A is also even signal, and e to the power of minus a into mod t. So this is also even signal. I have given the graphs of for all these things. Cos t is an even signal. Delta of t is an even signal. A is also even signal, and e to the power of minus a into mod t is also even signal, because they are going to satisfy the property which is f of minus t is equal to f of t, because cos of minus t is equal to cos t, delta of minus t is equal to delta of t, and a is nothing but it is always a. And here if you substitute mod of t is nothing but here f of minus t is equal to mod of minus t is equal to plus t only. So always you are going to get the same thing. Therefore we can say that a signal, the even signals are, so the even signal means a signal is going to satisfy f of minus t is equal to f of t, symmetric with respect to the axis. Those signals are called as even signal. The best examples are cos t, delta of t, a, and e to the power of minus a into mod t. And the examples of R signals. What's the meaning of R signals? R signals means if f of minus t is equal to minus into f of t and is symmetric with respect to the axis, those signals are called as the R signals. The best examples are sin t, u of t minus u of minus t, and m into t. All these are called as the R signals. Mt means it's a straight line, the slope of m. So definitely we can say at t is equal to 1 its value is plus 1, and at t is equal to minus 1 its value is equal to minus n. So both are of opposite values. So definitely we can say it is nothing but R signal. So f of minus t is equal to minus into f of t. This is going to satisfy this property. So sin of minus is nothing but minus into sin t, it is minus of f of t. Yes, it is also R signal. So any signal is going to satisfy the property f of minus t is equal to f of minus of f of t. Those signals are called as the R signals. So what are the best example? Sin t, p of t minus u of minus t. So this also can write signum of t. I have already told you. Signum of t. Signum of t is nothing but u of t minus of u of minus t. I have already told you, right? Signum of t is nothing but u of t minus u of minus t. I have already explained this formula also I have given. So these things always you have to keep in your mind. So now the next thing is, suppose C is a complex number. C is equal to a plus ib. C is basically a complex number. It has a real part and an imaginary part. It is a rectangular format, right? So I want to convert into polar format. Means the magnitude and the angle, which is root over a square plus b square into face angle of tan inverse of b by a. So it will have the magnitude as well as the face angle. So you can see C is equal to a plus ib. C is a complex number. A plus ib in the rectangular format. If you want to write in the polar format, it will become root over a square plus b square into face angle of tan inverse of b by a. What is C bar? C bar means complex conjugate. So I will become minus a, plus I will become minus a. That's it. So a minus ib. If you want to write in terms of the polar format, the magnitude is root over a square plus b square, and the face angle is tan inverse of minus b by a. So minus will come outside. So because tan inverse of minus will come outside, so minus tan inverse of b by a. So this point always you have to keep in your mind. So C bar is the mirror image of C with respect to x-axis. Because here plus ib and minus ib and x-axis point is same, so they are basically mirror image with respect to x-axis. So you can see clearly if this is the a plus ib, so this will be a minus ib. So therefore they are mirror image with respect to x-axis. So replace plus i by minus i. That's it. So replace the plus i by minus i or minus i by plus i in order to get the complex conjugate. So therefore complex conjugate for C bar. So C bar is the mirror image of C with respect to x-axis. So I have drawn the rectangular format as well as the polar format also I have given here. So integration of 0 to 2 pi sin t into dt, it's always equal to 0 because sin t period is 2 pi. Sin t period is 2 pi, right? Sin t period is 2 pi because here omega is equal to 1. Sin omega t, omega is equal to 1. Omega is nothing but 2 pi f. 2 pi f is equal to 1. Omega is equal to 2 pi by t. So sorry, 2 pi by t. So 2 pi f or 2 pi by t you can say. 2 pi by t is equal to 1. So t is equal to 2 pi. Over time period is equal to 2 pi. So here sin omega t. So omega is equal to 1. Omega 2 pi by t is equal to 1. So t is equal to 2 pi. T is the time period. So there is only one cycle in 2 pi. So when you given 2 pi, we have only one cycle. When you given 2 pi, we have only one cycle. From 0 to 2 pi, we have only one cycle. So only one cycle in 2 pi. So if you are doing integration from 0 to 2 pi, positive area and negative area, they are going to get cancelled, and finally you are going to get the value as 0. Similarly, integration of 0 to 2 pi sin kt dt. See, what is the omega? Omega is equal to k. And omega, it is nothing but 2 pi by t. So 2 pi by t is equal to k. So t is equal to now 2 pi by k. So the time period now 2 pi by q on time period. 2 pi by k is a time period. So how many signals are going to present in? So one signal, one cycle in 2 pi by k. So k cycles in 2 pi. So we are going to get k cycles in 2 pi. So we are going to get k cycles in 2 pi. As you can see clearly, the time period is equal to 2 pi by k. So one cycle you are going to get in 2 pi by k. Multiply by k on both sides. So therefore k cycles you are going to get in 2 pi. So k cycles you are going to get in 2 pi. So if you do the integration over 2 pi, positive and negative they are going to get cancelled, and finally you are going to get its value is equal to 0. Similarly, integration of 0 to 2m pi sin kt dt. What is this value? Same thing. Here omega is nothing but k. Here omega is equal to 2 pi by t is equal to k. So t is equal to 2 pi by k. So one cycle we are going to get in 2 pi by k. One cycle we are going to get in 2 pi by k. But here basically now multiply by 2m pi. So multiply by 2m pi. So multiply by 2m. Basically multiply by. So what I have to do? Basically, you see clearly, one cycle you are going to get in 2 pi by k. So what I have to do? Simply listen carefully. So k cycles you are going to get in 2 pi. So k cycles you are going to get in 2 pi. Suppose if I multiply by again m in both sides, then I am going to get km cycles in 2 pi m. So I am going to get km cycles. So k is an integer, m is also integer. So you are going to get overall integer. So this number of cycles you are going to get in 2 pi m. So therefore, what we are going to get? This number of cycles means positive and negative area both they are going to get cancelled. So finally, again its value is equal to 0. So therefore, what you can write here? So what you can write here? Finally, we can write here k into m. This number of cycles you are going to get in 2 pi into m. So you are going to get k into m number of cycles you are going to get in 2 pi into m. So as you can see clearly, one cycle is time period of 2 pi by k. So multiply by k on both sides, we are going to get k cycles in 2 pi. But I want in a period of 2m pi, how many number of cycles are present? So multiply by m on both sides, then we are going to get km number of cycles we are going to get 2 pi m period. So km number of cycles are going to get in 2 pi m period. Then if these km cycles are going to get present, so positive and negative they are going to get cancelled, and finally you are going to get its value is equal to 0. So here k and m, all these are integers only. So these ones always you have to keep in your mind. So now the next thing is sin t. I have already told you that omega is equal to 1. Omega is equal to 1 means 2 pi by t is equal to 1. So t is equal to 2 pi. So therefore, one cycle you are going to get in 2 pi period. So one cycle you are going to get in 2 pi. So what's the time period? 2 pi. Just now we have discussed that. Sin 2t. Sin 2t means omega is equal to 2. Omega is equal to 2. Omega is equal to 2 means what we can do? Just simply you can do the analysis. So omega is equal to 2. Omega is equal to 2 means 2 pi by t is equal to 2. So what is the time period? Time period is equal to pi. Time period is equal to pi. So 2 pi by 2 is nothing but simply you can do the analysis, right? So here basically is this right? Here we are doing the 2 by 2t. Represent 3 by 2t means here we have to divide by 2. So 2 by 2 is nothing but pi. So one cycle you are going to get in pi. So 2 cycles you are going to get in 2 pi. That's it. Similarly, sin 3t. Sin 3t means here you have to divide by 3. So 2 pi by 3. So time period is 2 pi by 3. So 3 cycles you are going to get in 2 pi. So one cycle in 2 pi by 3 means 3 cycles you are going to get in 2 pi. Similarly, sin omega naught t. So now what we can say was the time period 2 pi by omega naught. So 2 pi by omega naught. So one cycle you are going to get in 2 pi by omega naught. So omega naught cycles you are going to get in 2 pi. Similarly, sin k omega naught t. So what's the time period? 2 pi by k omega naught. So one cycle you are going to get in 2 pi by k omega naught. So k into k omega naught cycles you are going to get in 2 pi. Same thing. Listen carefully. Sin t. Sin t means omega is equal to 1. Omega is equal to 1 means 2 pi by t is equal to 1. So t is equal to 2 pi. So time period is equal to 2 pi means one cycle we are going to get in 2 pi. Sin 2t means you replace t by 2t means you have divided here. Scaling means you have divided here. So 2 pi by 2 means one cycle we are going to get in pi. So if you are going to get one cycle in pi means two cycles you are going to get in 2 pi. Sin 3t means divided by 3. So 2 pi by 3. One cycle you are going to get in 2 pi by 3. So 3 cycles you are going to get in 2 pi. Similarly, sin omega naught t means time period is 2 pi by omega naught. So we can say one cycle you are going to get in 2 pi by omega naught. So omega naught cycles you are going to get in 2 pi. Similarly, sin k omega naught t time period t by 2 pi by k omega naught. It's a time period. One cycle you are going to get in 2 pi by k omega naught. So k into omega naught number of cycles you are going to get in 2 pi. That's it. Very simple concept. Now e to the power of jt. E to the power of jt. What is the meaning of e to the power of jt? E to the power of jt time period is 2 pi. Why it is like this? See, why it is like this? Because what's the meaning of time period? F of t plus t should be equal to f of t. Then we can see the signal is to periodic signal. So v plus t by 2 plus 2 pi. And what you are going to get? T plus 2 pi. And what you are going to get? E to the power of jt into e to the power of j 2 pi. E to the power of j 2 pi is something like 1. So e to the power of jt we are going to get. So f of t plus t is equal to f of t we got. So what's the time period? Time period is equal to 2 pi. So e to the power of jt has a time period of 2 pi. E to the power of j omega naught t. Once it replace t by omega naught. So therefore you have divided by omega naught, right? So time period is 2 pi by omega naught. E to the power of jk omega naught t. It is a time period of 2 pi by k omega naught. Because e to the power of jt has a time period of 2 pi. E to the power of j omega naught t means we have replaced t by omega naught. Please we have replaced, we have divided by omega naught here. So replace by divided by omega naught. Here we are going to replace t by k into omega naught t. Scaling factor is k into omega naught. So here you have divided 2 pi by k omega naught. That time period is 2 pi by k omega naught. So this is a very simple thing. So now e to the power of j omega naught t. It's a basic continuous periodic signal. By using this we can represent any periodic complex signal. So listen carefully. It is a basic continuous periodic signal. By using this we can represent any periodic complex signal. E to the power of j omega naught t means e to the power of j theta is equal to cos theta plus j sin theta. E to the power of j theta is equal to cos theta plus j sin theta. E to the power of I theta is equal to cos theta plus I sin theta. It is a basic continuous periodic signal. What's the period here? 2 pi by omega naught. By using this we can represent any periodic complex signal. So we can say e to the power of j omega naught t is called as a basic continuous periodic signal. By using this we can represent any periodic complex signal. So this is nothing but it is a very basic continuous periodic signal. By using this we can represent any periodic complex signal because e to the power of j omega naught t is nothing but cos omega naught t plus j sin omega naught t. So that is the reason by using this we can represent any periodic complex signal. So we can say it is a very basic continuous periodic signal. So by using this we can represent any periodic complex signal. So finally I can say e to the power of j omega naught t, which has a time period of 2 pi by omega naught. So this is a very basic continuous time periodic signal. So by using this we can represent any continuous time periodic complex signal because e to the power of j omega naught t is nothing but cos omega naught t plus j sin omega naught t. So by using this we can represent any continuous time periodic complex signal. So this is a point always you have to keep in your mind. Now the next point is cos omega naught n, sin omega naught n, e to the power of j omega naught n. These are the basic discrete time signals. By using this we can represent any discrete periodic signals. See cos omega naught n, sin omega naught n, and e to the power of j omega naught n. These are called as a basic discrete time signals. So by using this we can represent any discrete periodic signal. In the time domain means I can say in the time domain means cos omega naught t, sin omega naught t, and e to the power of j omega naught t. These are also the basic continuous time periodic signals. So by this we can represent any periodic signal. Similarly, here also cos omega naught n, sin omega naught n, and e to the power of j omega naught n. These are the basic discrete time signals. By using this we can represent any discrete periodic signal. The next point is the minimum number of samples taken by discrete time periodic signal f of n to represent itself is defined as its fundamental time period n. As n is measuring number of samples, it must always be an integer in contrast to fundamental time period t of a continuous time periodic signal f of t. which can consider any real number. So basically, for continuous time f of t, the time period is t. T is a real number. It can take any value. Means it's a can take is a real value. Means it can take even the fractions. But in the case of discrete time domain, the n is always an integer because the time period is always an integer because here if the small n is agreement with the integers, so definitely capital is also integers. So what's the meaning of time period in the case of the continuous time domain? Means after a certain time, the signal is going to repeat its waveform. That is called as the time period in the continuous time domain. And here, in the case of the discrete time domain, the n represents the number of samples. After that, again, the signal is going to repeat. The number of samples is nothing but that is time period in the discrete time domain. After that time, the same thing is going to get repeat again. So the minimum number of samples which is taken by discrete time periodic signal f of n to repeat itself is defined as its fundamental time period n. As n is measuring number of samples, it must always be an integer in contrast to fundamental time period t of a continuous time periodic signal f of t, which can consider any real number. So I have already told you one important point. In the case of continuous time f of t, what's the meaning of time period? Time period means the signal is going to repeat its waveform after a certain amount of time. That is called as a time period. In the case of discrete time domain, the fundamental time period is nothing but is a number of samples that are going to repeat after a certain time. The number of samples in a given signal f of n after a certain time it is going to get repeat. Those number of samples is called as a time period. So the minimum number of samples is taken by discrete time periodic signal f of n to repeat itself is defined as its fundamental time period n. As n is measuring number of samples, it must be always an integer in contrast to fundamental time period t of a signal of a continuous time periodic signal f of t, which can consider any real number. The next thing is the sum of two continuous time periodic signals may or may not be periodic, but sum of two discrete time periodic signals is always periodic. I've already told you. Suppose if you take in the continuous time domain, if you take two continuous time periodic signals and if you do the arithmetic addition of these two signals, the resultant signal can be periodic or it may be periodic. But in the case of discrete time domain, if you take the two discrete time periodic signals and if you go for the addition subtraction, the resultant is always a periodic signal. So therefore, the summation of two continuous time periodic signals can lead to periodic or non-periodic signal, but the summation of the two discrete time periodic signals is always periodic. So the summation of the two continuous time periodic signals may or may not be periodic, but the summation of two discrete time periodic signals is always periodic. So this one always you have to keep in mind. The summation of two continuous time periodic signals may or may not be periodic, but the summation of the two discrete time periodic signals is always periodic. So this point always you have to keep in mind. So therefore, the summation of two continuous time periodic signals may or may not be periodic, but the summation of the two discrete time periodic signals is always periodic. So this point always you have to keep in mind. So therefore, we can say the summation of two continuous time periodic signals may be periodic or may not be periodic, but the summation of two discrete time periodic signals is always periodic. So this point I've already told you. So in the case of discrete time domain, I've already told you. In the case of discrete time domain, suppose f of n is equal to f1 of n plus or minus f2 of n. Then if f1 of n is having a period of n1 and f2 of n is having a period of n2, then what is the overall period of f of n, which is nothing but suppose f of n is having a period n. I already told you the discrete time domain, if you take two discrete time periodic signals and if you do the addition subtraction, resultant signal is always a periodic signal, and let me assume it has a fundamental period of n. So n is always equal to LCM of the n1 and n2, n1 and n2. So this point always you have to keep in mind. So therefore we can say that in the case C, the summation or the subtraction of two continuous time periodic signals may be periodic or may not be periodic, but the summation subtraction of two discrete time periodic signals is always a periodic. So this point always you have to keep in mind. So you can see in the case of discrete time domain, f1 of n is a periodic signal, the period of n1, and f2 of n is also a periodic signal with a period of n2. So if we do the additional separation of these two signals, the resultant signal is always a periodic and its period is n. So n is the LCM of the n1 and n2. So these point always you have to keep in your mind. So now the next point is, suppose if f of t is equal to e to the power of minus at into u of t, if f of t is equal to e to the power of minus at into u of t, so what is the energy which is present in the signal f of t? So you know the basic formula. Energy is nothing but energy is equal to integration of t is equal to minus infinity to plus infinity mod of f of t whole square into dt. See, you have to use always the modulus of the f of t. See, modulus of f of t is equal to f of t for real signal. And for complex signal, we have to take the magnitude value, which is under root of a square plus b square. I've already told. As the real signal, so magnitude of f of t is nothing but f of t only. The substance simplify. And finally, if you substitute the limits, finally we are going to get its value is equal to 1 by 2a joules, because the energy unit is joules, right? So therefore 1 by 2a joules. So for f of t is equal to the power of minus at into u of t, the energy which is going to present in the signal is nothing but 1 by 2a joules. So we can say for the signal f of t is equal to the power of minus at into u of t, the energy which is going to present in the signal is nothing but 1 by 2a joules. So finally I can say, see, you know the basic formula, energy is equal to energy which is going to present in the signal f of t is equal to integration from t is equal to minus 70 plus 70 mod of f of t whole square dt. So just substitute the signal and do the integration and substitute the limits. Finally we are going to get 1 by 2a. So therefore we can say for the signal f of t is equal to the power of minus 80 into u of t, the amount of energy present in the signal is equal to 1 by 2a joules. So this is the correct solution of this question. This is the correct point always you have to keep in your mind. So now the next thing is, impulse signal is neither energy nor power signal. So impulse signal is neither an energy signal nor a power signal. So why it is like this? Because the energy is equal to infinity and the power you are going to get infinity. That is the reason we say this is called as the, so that is the reason it is called as the, see, I have already told you, if a signal is said to be energy signal, when I have already told you a signal is said to be energy signal when energy is equal to finite and the power is equal to 0. A signal is said to be power signal when energy is equal to infinite and the power is equal to finite. A signal is said to be not an energy signal. It is not an energy signal. It is not a power signal when energy is equal to infinity and power is also equal to infinity. So in the case of impulse signal, the energy is equal to infinity as well as power is also infinity. That is the reason we say the impulse signal is neither an energy signal nor a power signal. So finally I can say a signal is said to be energy signal when the energy is equal to finite and power is equal to 0. A signal is said to be power signal when energy is equal to infinity and power is equal to finite. A signal is said to be either energy signal nor power signal when energy is equal to infinity and power is equal to infinity. So therefore, impulse signal is said to be neither energy signal nor power signal because energy is equal to infinity and power is also equal to infinity. So finally, I can say that a signal is said to be energy signal when energy is equal to finite and power is equal to 0. Similarly, a signal is said to be power signal when the energy is equal to infinity and power is equal to finite. So a signal is said to be neither energy signal nor a power signal when it has the infinite energy and infinite power. In the case of impulse signal, the energy is equal to infinity and the power is equal to infinity. So because of this reason only we say it is neither energy signal nor a power signal. This basically I had cleared this in my class also. So I kindly request you to listen my signal assistant classes so that you can easily able to understand why it is not an energy signal and also not a power signal. The next point is, for any signal, if we express its equation, it is called as the deterministic signal. So for any signal, if we express its equation, it is called as the deterministic signal. So suppose if a waveform is there, so you have represent some equation. So you know at each and every time what is the value of a signal, you know. Means for a given signal you have given some equation, there it is called a deterministic signal. Means you know at the future values and the past values and the present values, you know what is the value which is going to possess by that waveform, you know, with the help of that equation. So that is the reason it is called as the deterministic signal. So for any signal, if we express its equation, it is called as the deterministic signal. So for any signal, if we are going to express its equation, it is basically called as it is called as a deterministic signal. So therefore, we can say if you are going for any signal, if you are going to express its equation, it is called as the deterministic signal. So in simple words, I can say like this. Suppose for a given signal, we are given some equation. So with the help of equation, you know at each and every value of time, what is the value of the signal, you know, with the help of this equation. So for any signal, if you are going to represent with the help of that equation, then that is called a deterministic signal. So for any signal, if you are going to express its equation, then it is called as the deterministic signal. So for any signal, if you are going to express its equation, it is basically called as the deterministic signal. And the next point is for any signal, if we cannot give expression of the signal, but we can estimate or expect it, then it is called as the random signal. For any signal, if we cannot give expression of the signal, but we can estimate or expect it, then it is called as the random signal. So what is the best example? It is the information signal and the noise signal. So basically, suppose if there is some signal, for that signal we can't provide some exact equation, or then that is called as the random signal. So for any signal, if we cannot give expression of the signal, but we can estimate or expect it, then it is called as the random signal. And the best example is the information signal as well as noise signal. So noise signal, we cannot give an exact, for noise signal we cannot give an exact expression, but we can estimate it or we can expect it. That is called as the random signal. So for any signal, if we cannot give expression of the signal, but we can estimate it or we can expect it, then it is called as the random signal. The best example is the information signal as well as the noise signal. So finally, I can say that for any signal, if we cannot give an expression of the signal, but we can estimate it or we can expect it, then it is called as the random signal. And the best example is the information signal as well as the noise signal. So finally, I can say that suppose there is one signal. By that signal, we cannot express with any equation, then that is for the random signal. And the best example is the information signal and the information signal as well as the noise signal. So for noise signal, we cannot give any expression, but we can estimate the graph, that's it. So that is the reason it is called as the random signal. The next point is, if f of t is equal to 0 for t less than 0, it is called as a causal signal. And if f of t is not equal to 0 for t less than 0, it is called as the non-causal signal. Say what I told you, causal signal means if f of t is equal to 0 for t less than 0, then it is called as a causal signal. And if h of t is not equal to 0 for t less than 0, then it is called as a non-causal signal. Suppose for a given LTI system, if you are going to give the impulse input and you got the impulse response h of t. Suppose if h of t is equal to 0 for t less than 0, then the h of t is a causal signal and the LTI system is also a causal LTI system. Listen carefully. For a given LTI system, if you are going to give the impulse input delta of t and you are going to give the impulse response h of t, if h of t is equal to 0 for t less than 0, then we can say it is a causal signal. H of t is a causal signal and the system is said to be causal LTI system. So therefore we can say if the impulse response is a causal signal, then the LTI system is also a causal system. This point always you have to keep in your mind. So what's the meaning of causal system? Causal system means the output is going to depend only on the past values of the input or the present values of input, but not on the future values of input. That is the reason it is called as the causal LTI system. So finally, if f of t is equal to 0 for t less than 0, then it is called as a causal signal. If f of t is not equal to 0 for t less than 0, then it is called as a non-causal signal. Suppose for an LTI system, if you are going to give the impulse input delta of t, then we are going to give the impulse response h of t. If h of t is equal to 0 for t less than 0, then h of t is a causal signal and the LTI system is said to be a causal LTI system. This point always you have to keep in your mind. The next point is, if the magnitude of the f of t, the magnitude of the, we can say the modulus of the f of t, if it is going to lie between the less than or equal to m means it is going to lie only in the range of m. M is a finite value for all values of time, then f of t is said to be a bounded signal. See, basically, if the magnitude of the f of t, if it is going to lies between the m, if it is lies in the range of m, then we can say that it is less than or equal to m means the magnitude value is going to lie only below the m or exactly equal to m, but not above that one. Where m is a finite value for all the values of time, then definitely we can say that signal f of t is said to be a bounded signal. Suppose if m is equal to infinity means we say it is an unbounded signal. If m is a finite value means we say it is a bounded signal. So therefore, if the we can say if the magnitude of the f of t is less than or equal to m, then m is a finite value for all values of time, then the signal f of t is said to be a bounded signal. So if the magnitude of the f of t, if it is less than or equal to m, where m is a finite value for all the values of the time, then the signal f of t is said to be the bounded signal. So finally, I can say if the magnitude of the f of t, if it is less than or equal to m, where m is a finite value for all the values of the time, then the signal f of t is said to be a bounded signal. So finally, I can say, suppose if you take a signal f of t and you take the magnitude of that value, means the amplitude value. Amplitude value we are going to see the signal f of t is going to lie between the range of m, where m is a finite value for all the values of the time t. When the given signal f of t is said to be a bounded signal. Suppose if m is equal to infinity means then we say it is a unbounded signal. That's it. The next point is the analog signal. The analog signal, digital signal, is based on the y-axis. The continuous time and discrete time is based on the x-axis. Very simple. Analog signal and digital signal is based on the concept of the y-axis, and the continuous time and discrete time is based on the x-axis. Very simple. See, analog signal and the discrete and the digital signal is basically based on the concept of the y-axis, whereas the continuous time and discrete time is based on the x-axis. Very simple. Continuous time means it is going to take all the values of the t, and discrete time means only the integer values of the time. Whereas the continuous analog signal means it can take any value on the y-axis, but the digital signal means it can only take some particular range. It can take only some particular range, and a particular range only it can take either 1 or either 2 or either 3 or either 4 like that. Analog means it can take 1.1111, 1.1112 like that. So therefore we can say that the concept of the analog signal and the digital signal is based on the y-axis, and the concept of the continuous time and the discrete time is based on the x-axis. So therefore we can say the concept of the analog signal and the digital signal is based on the y-axis, and the concept of the continuous time and discrete time is based on the x-axis. So finally, I can say the concept of the analog signal and digital signal is based on the y-axis, and the concept of the continuous time and discrete time is based on the x-axis. So finally, I can say the concept of the analog signal and digital signal is based on the y-axis, and the concept of the continuous time and discrete time is based on the x-axis. Continuous time means it can take any value of time. Discrete time means it can take all the integer values of the time. And the analog signal means it can take any value on the y-axis. Digital signal means it can take only some particular steps only, it can take only some particular values only it can take on the y-axis. So finally, I can say the concept of the analog signal and the digital signal is based on the y-axis, and the concept of the continuous time and discrete time is based on the x-axis. The next point is, by using transfer function or the state variables, we can model the system. So by using the transfer function or the state variables, we can model the system. So by using the transfer function or the state variables, we can model the system. So basically, you take any system, that system we can model it either by using the transfer function or the state variables. I already told you. So by using this transfer function or the state variables, we can model any LTI system. It is basically LTI system only. So by using the transfer function or the state variables, we can model the system. So finally, So with the help of transfer function concept as well as the state variable concept, we can model the given system. So with the help of the transfer function model as well as the state variable model, we can model the system. So with the help of the concept of the transfer function as well as the concept of the state variables, we can model the system. The next thing is, if a system follows both homogeneity and superposition principle, it is called as a linear system. If it is not verified at least one of these principles, then the given system is said to be non-linear system. So if a system follows both the homogeneity and the superposition principle, then it is called as a linear system. If it is not verified at least one of the principles, then the given system is said to be a non-linear system. I have already told you what's the meaning of linear system. If you want any system to be linear, it should satisfy the two properties. One is the superposition property and the other is the homogeneity property. Superposition means when the new input is summation to the two previous inputs, the new input should be the summation of the two previous outputs. Then it is called as a superposition principle. Homogeneity means the input is multiplied by A, the output should also multiply the same amount of scalar quantity A. Then that is called as the homogeneity. So if these two properties are satisfied, then only we can say the given system is said to be a linear system. Suppose out of this, if any one is also failed, then by default we can say that the given system is said to be a non-linear system. Suppose if A is equal to 0, I have already told you for a given integer system, the input is f of t and the output is y of t. Suppose if the input is a into f of t, the output should be a into y of t. Suppose if A is equal to 0, means the input is equal to 0, then output should also equal to 0. So therefore, suppose if the input is equal to 0, then you should get the output as 0. Then only the given system is said to be an LTI system. So for 0 input, you should always get a 0 output. Then only we can say the given system is said to be a linear system. So for a 0 input, if you are given to get a 0 output, then only we can say the given system is said to be a, then only we can say the given system is said to be a, then only we can say the given system is said to be a linear system. So therefore, I have already told you, if you want any system to be a linear, it should satisfy two properties. One is the homogeneity property and the other is the superposition principle. Superposition principle means if the input is summation of two previous inputs, then the output should be the summation of two previous outputs. Then only we can say the given system is said to be a linear system. It is said to be a linear system. Sorry, superposition. It should be satisfied. Homogeneity means if the input is multiplied by A, then the output should also multiply the same amount of A. Then only we can say the homogeneity is satisfied. If these two points are satisfied, then only we can say the given system is said to be linear. If out of this, if any one is also failed, then the given system is said to be a non-linear system. So if suppose if A is equal to 0, means if the input is equal to 0, then output is also equal to 0. So for every 0 input, if you are going to 0 output, then we can say the given system is said to be a linear system. So now the next point is, for linear systems, if the input is 0, then the compulsory, the output has to be 0. This point I already told you. For linear systems, if the input is 0, then compulsory, the output also has to be 0. So for linear systems, if the input is 0, then compulsory, the output also has to be 0. So for linear systems, if the input is 0, then compulsory, the output also has to be 0. So for linear systems, if the input is 0, then the compulsory, the output also has to be 0. So this point always you have to keep in your mind. So for linear systems, if the input is 0, then compulsory, the output also has to be 0. So for only 0 input, if you are going to a 0 output, then we can say the system is said to be a linear system, because I have already told you, for a given system, for a given LTI system, if the input is f of t, then the output is also y of t. Suppose if the input is a into f of t, then the output is now a into y of t. Suppose if a is equal to 0, then the input is equal to 0, and the output is also equal to 0. So for every 0 input, you should get a 0 output. Then we can say the given system is said to be a linear system. So for linear systems, if the input is 0, then compulsory the output also has to be 0. So for linear systems, if the input is 0, then compulsory the output also has to be 0. So this point always you have to keep in your mind. Now, the next point that we are going to discuss, which is LTI. LTI means a linear time invariant system. LTI means linear time varying system. NLTI means non-linear time invariant system. NLTV means non-linear time varying system. only these four types of systems which are going to get possible. So we can say, see here, in the case of linear, there will be linear, non-linear. In the case of time variant, there will be time invariant or time variant. So different combinations, we can say linear time invariant system, linear time variant system, non-linear time invariant system, non-linear time variant system. So only these four types of systems are going to present in the practical world. So we can say the concept of the linear, the system can be linear or non-linear. In the case of time variant, the system can be the time invariant or time variant. So now we have two choices. So finally we are going to have total four choices: linear time invariant system, linear time variant system, non-linear time invariant system, non-linear time variant system. So therefore, LTI means linear time invariant system, LTV means linear time variant system, NLTI means non-linear time invariant system, NLTV means non-linear time variant system. So only these four types of systems which are going to present in the practical world. But only we are going to study only which is LTI systems. Out of these four systems, only we are going to study LTI systems only. So this is the only system which I am going to study in the course. So in physical system course, we are going to study only the LTI systems, but not the remaining three systems. So generally, NLTV appears more in the major, but we study only the LTI systems in this course. I have already told you, only the LTI systems, linear time invariant systems, only this type of systems that we are going to study in the course. But in the practical world, the systems are non-linear as well as the time variant system. But if you see the practical world, most of the systems are non-linear as well as the time variant systems. So if you see in the real world, most of the systems are basically non-linear as well as time variant. So, but in our course, we are going to study only those type of systems which are linear time invariant systems. So finally, I can say in the practical world, most of the systems are non-linear time variant systems, but we are going to study only which is LTI systems in this course. The next point is, if the system is causality, then I will do analysis. Otherwise, I won't do because it can't be physically realizable. I already told you. Suppose a given system is causal system, then only we can say the output is depending on the past values of the input or the present values of the input, but not the future values of input. Then we can physically build a system. But if a given system is a non-causal system, means the output is depending on the future values of the input, then we cannot build that type of systems in the real world. So only causal systems only we can build physically with our equipments, but non-causal systems we cannot build really. So theoretically we can say like that, or practically we cannot build them. So therefore we can say, if the system is causality, then I will do analysis. Otherwise I won't do because it can be physically realizable. So if the system is causality, then I will do analysis. Otherwise I won't do because it can't be physically realizable. So therefore, if the given system is causality, then only I can do the analysis. Otherwise I won't do because it can't be physically realizable. So I already told you, a given system is said to be causal if the output is depending on the partials of the input or the present values of input, but not on the future values of input. Then only we can say the given system is said to be causal system. So if the system is causal system, then only we can physically realizable, means physically we can build it. Suppose if the system is non-causal system, is the output is depending on the future values of the input, then basically we can't build it. So therefore we are not going to do the analysis for the non-causal system. So only we are going to do the analysis for only causal type of systems, but not for the non-causal type of systems. So these four knowledge you have to keep in mind. The next point is, even at one instant of time, if the output depends on the future values of the input, then the whole system is said to be non-causal system. I already told you, even for at least one instant of time, if the output is depending on the future values of the input, then the given system by default is called as a non-causal system. Even for at least one instant of time, if the output depends on the future values of the input, then the given system is said to be a non-causal system. So therefore we can say, even for any one instant of time, if the output is going to depend upon the future values of the input, then the whole system is said to be a non-causal system. So I already told you, even for at least one case, even for at least one instant of time, if the output is depending on the future also the input, and the given system is said to be a non-causal system. So finally, I can say, even for at least one instant of time, if the output depends on the variables of the input, then the given system is called as the non-causal system. So, if a system is said to be causal means for all the time, for all the values of the time, if the output is independent of the features of the input, then only we can say it is a causal system. Even for at least one instant of time, if the output depends on the future values of the input, then the given system is said to be a non-causal system. This will always you have to keep in your mind. The next point is, so what is the meaning of causal system? Listen carefully. I will tell you the detailed analysis regarding this one. What's the meaning of causal system? If x1 of t is equal to x2 of t for t less than or equal to t1, if you apply for the system, then the output y1 of t is equal to y2 of t for t less than or equal to t1. Suppose for a given system, if both the inputs are same for a certain amount of time, then both the outputs should be same for the same amount of time. Then carefully. Suppose for a given system, suppose if you are going to give two inputs which are same manner, and the output is also same up to that amount of time. So if x1 of t is equal to x2 of t for t less than or equal to t1, then y1 of t is also equal to y2 of t for t less than or equal to t1. So if the inputs are same up to certain amount of time, and the outputs are also same up to same amount of time, then we can say the given system is said to be causal system. So therefore, what is the meaning of causal system? As I've already told you, causal system means the output is the causal system is I've already told you. So what is the meaning of causal system? If the inputs are same after a certain amount of time, and the outputs are also same after the same amount of time, then the given system is causal system. Or you can also say, if the output is independent of the future values of the input, then also we can say the given system is said to be a causal system. A resistor is a static element, whereas the inductor and capacitor are the dynamic elements. I have already told you, in the case of resistor, V of t is equal to R into I of t. So, V of t, let me take it as the output and I of t is the input. So, we can say output is depending only on the, say, there is no memory. So, the present value of the voltage is going dependent upon the present value of the current I. So, that is the reason it is called as a static system. Whereas the inductor and capacitor, inductor is equal to V is equal to L di by dt. So I is equal to 1 by L integration over dV into dt. So voltage means the current is going to take the postulates of the voltage also. So because of this reason it is called as the static system. The capacitor I is equal to C dV by dt. So V is equal to 1 by C integration of the I into dt. So here the postulates of the currents are also taken. So that is the reason it is called as the dynamic element. So static means there is no memory. Dynamic means there is a need for memory. So it's a very simple thing. So therefore that is the reason resistor is a static element. There is the induction and capacitor of the dynamic elements. The next point is stable and unstable systems. So let me tell you the concept of stable and unstable systems. If the input is bounded and the output is bounded, then the given system is said to be a stable system. So bipolar stability means for every bounded input, if you are going to get a bounded output, then the given system is said to be a stable system. For every bounded input, if you are going to get a bounded output, then the given system is said to be bipolar stability. Even for at least one bounded input, if you are going to get an unbounded input, then the overall system is said to be an unstable system. Listen carefully. For every bounded input, if you are going to get a bounded output, then only we can say the given system is said to be a stable system. Even for at least one bounded input, if you are going to get a unbounded output, so even for at least one bounded input, if you are going to get an unbounded output, then the given system is said to be an unstable system. So listen carefully. For every bounded input, if you are going to get a bounded output, then the given system is said to be a stable system. Even for at least one bounded input, if you are going to get an unbounded output, then the given system is said to be an unstable system. So finally, I can say, for every bounded input, if you are going to get a bounded output, then the given system is said to be a stable system. Even for at least one bounded input, if you are going to get an unbounded output, then the given system is said to be an unstable system. So finally, I can say, for every bounded input, if you are going to get a bounded output, then only we can say the given system is said to be a stable system. Even for at least one bounded input, if you are going to get a unbound output, then we can say the given system is said to be an unstable system. So now the next point is here, let me write the conclusion. If mod of y of t less than or equal to n for all values of t, when mod of x of t is less than or equal to m for all values of t, if the signal is bounded and the system is also stable. So basically what is the meaning of this one? So for every bounded input, if you are going to get a bound output, then the given system is said to be stable system is the signals are bounded and the system is stable. The signal is bounded and the system is stable. So here the input signal is bounded signal and the output signal is also bounded signal for all the value of t, then the given system is said to be stable. So signals are always bounded and the system is always stable. So therefore you can say, as you can see, the input signal is bounded and the output signal is also bounded. So for every bounded signal we are going to get a bounded output. For every bounded input signal we are going to get a bounded output signal. So therefore we can say the given system is said to be a stable system. So signals are bounded and the system is stable. So signals are bounded and the system is stable. So this point always you have to keep in your mind. So therefore we can say that, finally I can say, for every bounded input, if you are going to get a bounded output, then we can say the given system is said to be a stable system. Even for at least one bounded input, if you are going to get an unbounded output, the given system is said to be an unstable system. So in this case, we are taking a bounded input. So mod of x of t always less than or equal to m for all the value of t. And output you are going to get a bound, which is mod of y of t less than or equal to n for all the value of t. Then we can say the signals are bounded. So we can say the system is said to be stable. Even if for at least one bounded input, if the output is unbounded, then the given system is said to be compulsory and stable. Even if for at least one bounded input, if the output is unbounded, then the given system is compulsory and stable. So even if for at least one bounded input, if the output is unbounded, then the given system is said to be compulsory and stable. As I already told you, even for at least one bounded input, if you are going to get an unbounded output, then the given system is said to be unstable system. So I already told this point out. Even if for at least one bounded input, if you are going to get the output as unbounded, then the given system is said to be compulsory and stable. So even if at least for one bounded input, if you are going to get an unbounded output, then by default we are going to get a unstable system. The next point is, system will be stable or unstable, but a signal will be bounded or unbounded. So signals are either bounded or unbounded, but a system can be stable or unstable. So bounded concept is valid for the signals, stable concept is valid for the system. So this is what I am trying to tell you. So bounded concept is applicable for the signals and a stable concept is applied for the system. So listen carefully, signal can be either bounded or unbounded. System can be either stable or unstable. So you can say the bounded concept is applied for the signals and the stable concept is applied for the systems. So therefore we can say bounded concept is applied for the signals and the stable concept is applied for the systems. So therefore the systems can be either stable or unstable and the signals can be either bounded or unbounded. The next point is, unstable system is also stable for few inputs. So we use only these inputs for this type of systems. Unstable system is also stable for few inputs. So use only those inputs for this type of systems. See, I've already told you. See, a system is said to be unstable means even at least for one bounded input, if you are going to get a unbounded output, then the given system is said to be unstable system. Means for other bounded inputs, the output you are going to get a bounded only. So use only those bounded inputs. So therefore you are going to get a bounded output, right? So you have to use those things. So unstable system is even at least for one bounded input, if you are going to get a unbounded output, then the system is said to be unstable system. Means for the remaining bounded inputs, the output is basically bounded output only. So instead of this, you are going to get unbounded output. Use that unstable systems for the bound output. That's it. So therefore, we can say basically we can use even the unstable systems also for our regular work also. Because why? See, for the remaining bound outputs, the system is also going to give the bound output only it is going to give. So that is the reason we have to use only for those type of inputs. So therefore we can say unstable system is also stable for few inputs. So we have to use only those type of inputs for these types of systems. So in simple words, I can say that even for at least one bounded input, if you are going to get the unbound output, then the given system is said to be unstable system, right? So as I already told you, we can use those systems for that type of bound output. So you can see clearly. Suppose, listen carefully. Suppose I have given input 1, input 2, and input 3. Input 1 is a bound input, input 2 is also bound input, and input 3 is also a bounded input. Suppose if I got the output 1 dash, 2 dash, 3 dash. Here, this bond 1 dash is a bound output, 2 dash is a bounded output, and 3 dash is a unbound output. So unbounded output, here bounded output, here also bounded output. But here also bounded input, here also bounded input, here it's unbounded input. So now, as you can say, this is also bounded input, input is also bounded here. So you can see the overall the system is said to be unstable system. Overall, the system is said to be unstable system because even for at least one bound input, if you are going to get unbounded output, then the given system is said to be stable. But for if you go for the input 1 and input 2, these are the bounded and output is also bounded. So use these unstable systems for use these type of inputs where the input is bounded as the output is also bounded. So therefore, we can say finally, even at least for one bounded input, if you are going to get an unbounded output, then the given system is said to be unstable system. So you can use the unstable systems also. For those, you have to use only those type of inputs so that we are going to get the bounded output. So now the next point is, a system is non-immutable if in one of the following two cases. A system is non-immutable in one of the following two cases. I have already told what is the meaning of this one. Immutable, non-immutable means we can say, I have already told, suppose if you take some system, suppose input A, you are going to get X, and output you are going to get Y. Suppose if you take another system, suppose if you are going to get X, then the system is called as the immutable for the first system. So two systems is called as immutable of the first system is for every unique input if you are going to get unique output. So therefore, for every unique output you are going to get the unique input, right? So therefore, for every unique input you should get a unique output. So therefore, by the is also true. So for every unique output also you should get a unique input. Then in that case we can say the system is said to be an immutable system. Non-immutable means suppose if you have more than one input, if it has same output, in that case also we can say it is a non-immutable system. So this is one of the things. If more than one input, if it generates same response, I have already told you, suppose if you have more than one input, if it is going to have the same output, then in that case the output doesn't know by what input I am going to get that response. So therefore it is also non-invertible. If a non-zero input generates a zero response, in that case also you can say it is a non-invertible. So for a non-zero input, if you are going to get a zero response, in that case also we can say the given system is said to be a non-invertible system. So therefore we can say that. So these are the two cases by which we can say the given system is said to be a non-invertible system. Yes. For if more than one input, it is going to generate the same response. And if a non-zero input, it is going to generate a zero response, then we can say the given system is said to be a non-invertible system. So finally, for more than one input, if you are going to get the same response, or for a zero input, if you are going to get a zero response. So for a non-zero input, if you are going to get zero response, then in this case, we can say the given system is said to be a non-immutable system. So I have already told you a system is said to be immutable when for every unique input you should get a unique output, or vice versa also true. For every unique output you should get a unique input. Then only we can say the given system is said to be an immutable system. Non-immutable means suppose for many input if you are going to get the same response, then in that case also we can say the given system is said to be a non-immutable system. And for non-zero input if you are going to get a zero output, then also in that case also we can say that given system is said to be a non-immutable system. So the next point is a to the power of n, u of n, convolution of u of n is equal to 1 minus a to the power of n plus 1 by 1 minus a into u of n. So this formulas I already told you, but let me repeat this one. A to the power of n u of n, convolution of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. A to the power of n u of n, convolution of b to the power of n u of n is equal to b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n, or you can write in the reverse also. Take minus the common denominator and take minus from the denominator. So minus minus cancels. We are going to get a to the power of n plus 1 minus b to the power of n plus 1 by a to the power of a minus b into u of n. So I recommend you to remember this way. So I recommend you to remember in this way, so that things are going to become very simple. You can remember anyway, but still I request you to remember this one. Suppose if b is equal to 1, if b is equal to 1 means we are going to get this case, right? Then if you substitute in place of b, if you substitute 1, then we are going to get this case 1. This result we are going to get. Substitute in place of b is equal to 1. So 1 minus a to the power of n plus 1 by 1 minus a into u of n. So I recommend you to remember only these two things. And the remaining third one you are going to get from this concept only. So a to the power of n u of n combination of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. And a to the power of n u of n combination of a to the power of n u of n is equal to b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n. So finally, I can say that a to the power of n u of n combination of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. And a to the power of n u of n combination of b to the power of n u of n is equal to a to the power of, I can say b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n. So these two formulas always you have to keep in your mind. And this formula you are going to get from this one just by substituting b is equal to 1. So finally, I can say a to the power of n u of n combination of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. And a to the power of n u of n combination of b to the power of n u of n is equal to b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n. So finally, I can say a to the power of n u of n combination of a to the power of n u of n is equal to a to the power of n into n plus 1 into u of n. And a to the power of n u of n combination of b to the power of n u of n is equal to b to the power of n plus 1 minus a to the power of n plus 1 by b minus a into u of n. So these two formulas always you have to keep in your mind. The next formula is the geometric series summation. Geometric series summation a plus ar square up to a into r power of n is equal to, what's the first term? A into 1 minus the ratio is r. My total number of terms are here 1, here 2 or 2n. So total number of terms are this is another 1. Total n plus 1 terms are there by 1 minus r. So always remember, in the case of the geometric series, the ratio between the two consecutive numbers is always r. Or you can say every so from starting onwards, if you multiply by r, you are going to get the second number. Again multiply by r, you are going to get the third number. So if you do the ratio, you should get r. So this first term is a into 1 minus r to the power of n plus 1 by 1 minus r. So here n plus 1 is nothing but the total number of terms which are present in this series. Total number of terms which are going to get present in this series. So it is n plus 1 in this case. So a into 1 minus r all to the power of n plus 1 by 1 minus r. So therefore, we can say that this formula always you have to keep in mind. So this is some of the geometric series a plus ar square up to a into r to the power of n, which is equal to a into 1 minus r to the power of n plus 1 by 1 minus r, where a is the first term and r is the ratio between the second and the first, or third and the second, or fourth and the third. Then n plus 1 means total number of terms are present in this series, which is n plus 1. The next thing is, here y of t is equal to f of t combination of h of t. Then y dash of t is equal to, I have already told you, which is f of t combination of h dash of t, or f dash of t into f dash of t combination of h of t. I have already told this concept, right? Because anyhow you should get the summations at the moment. Here f dash is 0. So 1 by 0 is equal to 1. So you should get like this. I have already told you. What I told you, basically, suppose y of t is equal to f of t combination of h of t. I have already told that. Suppose p the derivative of t is equal to mth derivative of t into the derivative of t. So their summation should be equal to p is equal to m plus n. I have already told this concept, that p is always equal to m plus n. So p the derivative of y is equal to mth derivative of f of t combination of nth derivative of h of t. So p is always equal to n plus n, where p is equal to 1. So if p is equal to 1 means, we can write like this, 1 plus 0 or 0 plus 1. We can write like this. So 0 is no derivative, take the signal as it is. That's it. So now, suppose if you want y of t, then we will do the integration of the y dash of t, then you are going to get y of t. So it's very simple. The integration derivatives are the same signal that you are going to get. So y of t is equal to integration over the minus into t y dash of t dt. So you know the derivative of the y of t. So if you want y of t, just do integration of the derivative. That's it. So y of t is equal to f of the combination of h of t. So y dash of t, that we will get this expression. Suppose if you want from y dash of t, if you want y of t means to integration of y dash of t, then we are going to get y of t. So y of t is equal to integration or the minus into t y dash of t into dt, and we are going to get the y of t. So this point I wanted to do so many number of times. So these things always you have to keep in your mind.